Grafer finns överallt.
Graphs are everywhere.
Graphen sind überall.
Alright, graphs are everywhere, aye.
Los grafos están en todas partes.
图无处不在。
Grafy są wszędzie.
Grafikler her yerde.
Graphs हर जगह हैं.
גרפים הם בכל מקום.
Grafi su všade.
I grafy no padu.
I grafi sono ovunque.
Grafikler her yerde.
Grafen sind überall.
Grafet janë gjithandej.
Graphs har jagä här.
Graphs berada di mana-mana.
Grafen zijn overal.
Grafen sind überall.
Graphs are everywhere.
Grafike je všude.
Graphలు ప్రతి చోట ఉన్నాయి.
Grafer finns överallt.
Grafen sind überall.
I grafi in padu.
Grafoች băietă-mălă.
Grafoak легкостиетен daude.
Графовые решения повсюду. Jitte gitte gravsign.
Grafer overalt.
Tu wozu gut sei.
Hey, Graphen sind allgegenwärtig.
Graphs ಎಲ್ಲ இடத்துலயும் இருக்கு.
Grafi so všude.
I grafici sono dappertutto.
Les graphes sont partout.
Графите са навсякъде.
頭無處不在。
Os grafos estão em todo lado.
Les graphes sont partout.
Ich grafikonot in den Holwandern.
Le grafische tutta basso.
Grafen sind überall.
Los grafos están
En todas partes.
Graphs har jagah.
Grafos hay en todas partes. Graphs are everywhere. Really? Are graphs everywhere? Yes, indeed. Graphs really are everywhere, and Cypher is used to query them.
Hello, good morning everybody. Welcome to today's Loads 2021 warm-up show, morning show.
Oh, and good morning to, good evening, good afternoon as well, because I know we get so many people from around the world coming in. So yeah, welcome. And I'm going to do my cheeky thing of doing the shout out. So I know it's a bit early for a lot of people. I know it's a bit late for other people, but come, tell us, where are you? Where are you tuning in from? Let's start this. It's always a bit of fun, and maybe we'll do this throughout the session before we kick off Node. So,
yeah,
where are we all tuning in from?
Where are we tuning in from? Maybe you start with that, Lou. So I'm tuning in from Munich, Germany. It's gonna be a hot and sunny day today, so that's why my window shades are down. It's gonna be hot and warm. So looking forward to the day with you on the shade inside. Where are you from?
Yeah, so I'm from London in the UK, and yes, I am in my personal sauna room. So I always have to point out, we've had, I'm not complaining, it's been beautifully warm in the UK, or certainly in the southeast. But yes, I am in my south-facing solid brick wall study, so I look forward to working on a good sauna session whilst we're presenting. But yes, look at this, we're coming in, right. Let's see where everybody else is coming in from.
Boy, wow, Kavji, that is early. Thank you for joining this time for you, so that's really great.
Yeah, have you at 4 o'clock in Uruguay? Wow, that's dedication. Good morning. I don't know. Is it good morning, good night? I'm confused. What's the correct terminology here?
You're awake, already awake.
Yeah. Good morning, Daniel, who's in Zug in Switzerland. Ismail, 9 o'clock. Yeah, 9 in France. So good morning, Ismail in France. Kim's tuning in from South African Stellenbosch. That's hang on. Oh, it's the same time. Is it South Africa's same time zone as the UK? I think more or less. Yes. So good morning. Good morning. I got Uhrat from Slovenia. Good morning. Good morning, Louise. Fellow Neophagea.
Yeah.
Good morning. Malama. Got Michael from Dresden. Good morning. We got Sai Kumar from India. Good afternoon.
Exactly. Good afternoon.
I noticed as well we've got Alex from Berlin in Germany, good morning, who will be joining us later as well.
Yes.
We're going to have him on air. So good morning. You're going to be joining us today. Wonderful. Oh, look at that. Sai's been waiting for this stream. I'm so excited. Oh, thank you for joining us. Glad to hear it. Who else have we got? Oh, we've been put in the challenge of saying the greetings in the local language. I think we may need to get a bit of help. You may need to actually tell us in the chat. I mean, I think we've got the German covered.
Yes, it's not so difficult. The other languages.
I feel like I should I need to put that down. I need to know how to say good morning in Hindi. I feel or good afternoon is more appropriate. I mean, I think I'd have to be up really early to be able to use the good morning in Hindi, but the good afternoon I think would be very useful. Wonderful. Okay. And again, anyone who's traipsing in, do give us a shout where you're located. We'd love to give you a shout. It's always exciting to see who's coming in from where.
Absolutely.
Yeah. So, right. I think we should probably have a quick peek at agenda, shouldn't we, before we continue?
That's a good idea. Let me slide that in. Here we go. So yeah, this is today's agenda. It's going to be a long morning and fully packed with lots of exciting sessions. So we are now at the 7. This is time zone showing in UTC because it's easiest, but you can adjust according to where you are. So yeah, we are currently in the opening slot, and we will have Priya Jacob, our fellow Neo4j colleague, joining us in a couple of minutes to go over our highlights of Nodes 2021, which everybody knows, hopefully, is starting today live at 2 p.m. CEST, 1 p.m. EST, and other time zones I've forgotten now. Sorry. In 5 hours, basically. So
that's all good.
Yeah, and and afterwards we have Polly Wong as a shout out back to 2020, Nodes 2020, who will be joining us at an ungodly hour. So I must apologize to her again. It's going to be 4 a.m. For her joining out of New York. But yeah, we will watch her presentation from last year again and talk to her about what's changed. It'll be interesting. We have a couple of these lined up. So you can see here Rajesh Getty is coming afterwards, also joining us for a live talk. Luan will join us later on as well on her session on Maltaware, discovering what to drink with Neo4j. I think it's probably a little bit early to open up a glass of whiskey, especially for us two, Lou, right? I think it's probably not a good idea, but maybe after it's a better time for that. And then we have like you said already, Alex and Anthony coming to join us to talk about our Neo4j community.
Yes. And we're also, for those of you as well, probably worth mentioning during that session, for those of you who are a bit new to Discord, so we have a bit of a story about Discord. So some of you maybe you've been using the Neo4j user Slack. So we made a decision early in the year to move over to Discord for a number of reasons. So the biggest reason being that there is a cap on a number of people who can, number of messages that you can have on the free tier of Slack. So I think you can have up to about 60,000 messages. And then what happens, the older messages get truncated and they disappear forever, never to be seen again. And the big challenge behind that is there's a lot of really interesting debates. People ask really good questions. And if you're a big user of these kinds of, oh, it's 10K limit, it's not even 60,000. It's even more aggressive than that. I've just been corrected by Michael. And the thing that you've got to bear in mind with that is, I'm thinking, if you're anything like me, I mean, like my very questionable knowledge storage system that is certainly on our work Slack is I'll remember a conversation and I'll go search for it. And can you imagine if you asked something and then like 2 months later it disappears? So there's a real problem where you could really imagine, you put yourself in the shoes of somebody you've asked a question, you know, maybe you're struggling with Cypher or how to get something working with APOC or something like that. And then you want to go back to that conversation and it's disappeared. And us moving on to the next tier of Slack was like prohibitively expensive. I think it was something like $6 or $8 per person per month. And you think about, we've got a few, you know, hundreds, if not 1,000 odd people on there. It was just, that would have been crazy expensive for us to be able to do that. So we had a look around and Discord seemed like a really good fit, especially as we're doing stuff with Twitch. And there's a lot of people already on Discord as well. So I know, Alex, sorry, I'm going to keep quiet because you did a lot of stuff around that. So you want to talk a little bit about what you did and how we got there?
Yeah, I can do that. We can maybe show the server later on when we talk in the session. And the point of Discord, like you said, is that is more interactivity is possible also. So not just because of the prohibitants with the message deletion, but also it's like a fun place with lots of interactions. We have a couple of bots that help us out with things. We have a couple of nice tools. You can inside Discord, you can share your screen, you can share your audio, you can ad hoc create a work group together with a couple of people. So for example, for the GraphQL hackathon, we already used Discord, right? So made use of that. So we open this up and people can find partners there easily to work together on a project for a hackathon or for something else. And we want really to make Discord as a place for the whole community to come together and to exchange ideas and to discuss things, but also to use this as a platform to work out if need be. So it's really possible. So you can create a little group for your colleagues on your Neo4j project there, and we offer this as your hub, and you can join us there. It's easy, and you always have somebody from Neo4j around, the great Neo4j ninjas, our ambassadors and Neo4j experts from the community, and they are eager to help and really will jump in and if you struggle on something. So it's really easy. And I think it's a fun place. So check it out if you haven't.
Yeah, please do. So if you're curious for the link, if you want to get set up on there, that's dev.neo4j.com/chat. And I'm sure actually you can probably hit the little. I think Michael's put the link in. So if you click that,
link, put a link in as well. If you're on Twitch, watching on Twitch, you can do !Discord, and then you get the link. As you can also do !notes, and you get the link to notes. So you can go there. If you're on YouTube, click on the link that we have put in the chat. Yeah.
Perfect. Oh, better quickly and say good morning to Janos and Omka. Good morning. Welcome for joining us. And what I was going to say quickly as well, yeah, so that's what's happened. So join us, and there's lots of fun stuff going on. And I'm going to do a quick shout out to Johannes. Oh my goodness, 1 second. Johannes Donut, who's put together this really cool bot. So it is very early stages of development, but it's brilliant. So basically, Johannes has put together a speed chat bot on Discord. So it's a speed chat bot, Discord bot, and yeah, we're gonna have a play with that later.
Yeah, that's so cool. I mean, it's really great, Johannes. So cool. And that's fun, and that's I think we're gonna use it during nodes all over, but we will have a play, like you said, with it later.
Oh yeah, I think we should have a go. So let's see what the excitement is. So if you're joining on Discord, so what you need to do, we've got a set of secret channels just for nodes.
Ooh, secret channels. What do you need to do to get access to the secret channel, Lou? What do I have to do?
So when you go onto Discord, you need to do !nodes, all in like no spaces or anything like that. And then Greta will bestow you a special Nodes 2021 role. And then, as if by magic, a set of text and audio channels will appear. And by all means, if you want to jump into a channel now and you want to sort of chat and banter whilst we're on now, so you can either do it earlier or later. So what you can do is you'll notice some of the channels have a little picture of like a speaker on them in the nose thing. So literally you can go in there, and if somebody else comes along, you can go in there and it will basically like start a chat voice channel. So think about it's like a phone, dynamic phone. Oh, we're getting a demo. A demo.
Let's do that. So here I see a couple of people already did it. So yeah, like you put !nodes and then you get it. Or you can also, if you don't want to do that, you can go into the nodes channel here and click on that little yellow circle in that tagged article, and then you get to get access to the Neo4j tracks, which you can then see. Michael's post, and you can say hi from Twitch.
Hey. Oh, and Kim's just asked. Kim's just opened Discord for the first time. So where would they put in !nodes? You can put it in anywhere, can't you?
You can put it basically anywhere. Yeah. Pick any channel. I mean, most likely you started with the intro, introduce yourself, or the banter channels. Really, every channel is fine. At the moment, it will reply back to you with an embed message. I guess if we realize this is a bit spammy, I will switch it over to a private reply.
I just I hope we don't end up with like 2,000 people going
Exactly, yeah.
No.
It's maybe a little bit much. Maybe I switch that off.
we may tweak it slightly. Greta will still let you know if you've been added.
Yeah, exactly.
And actually, no, quickly, just if you go to the secret channels, we just show what the secret channels there for those who are curious.
Absolutely, yeah. Here we go.
So you'll notice the top 5. So those are going to line. So those probably make more sense later on in the day when we kick off with nodes proper. So if you want to chat about a talk that was in that track, that's a great place to do it. And underneath you see 5 more channels with the same name, and we've called them voice chat. So hopefully that's illustrative. So what happens there? You get a little picture of the speaker. If you go in there, then you basically immediately start a voice chat. So if your microphone's on, it'll start up, and then somebody else comes in there, they'll be able to start having a conversation. So you'll be able to chat. And this is one feature I absolutely love about Discord. There's none of this, let's schedule a meeting or let me call you. The fact that you can just wander in and just start chatting is super cool.
It's super good, yeah. Hi, Kate.
So if any of
I
you
see you in the chat, so hello.
Exactly. So if anybody wants to, if you want to start, if you want to form like some informal viewing parties or anything like that, you've got those available for you, as well as starting like your own private chats there. You have the option too. And I can see, Kim can see the secret channels. So have a look at that, and we're going to have a play with the Discord bot too. So I just wanted to quickly flag those for those of you who are a bit new. Got a few more people coming in. So good morning, Tariq. Good morning, Enzo. Welcome. And you got Nikunj as well from Nick. Based in Singapore. Good afternoon.
Good afternoon, Nick.
Right. Okay, so I think we should probably have a quick look at the tracks before our first guest joins us.
Let me switch over again to here. Yep, here we go.
So yes,
I guess we did that already, kind of. What is nodes? But
we should probably quickly mention a bit the thing that's a bit special about nodes this year. So
yeah, do you want to?
Yeah, sure. So the thing to bear in this year, and like, thank you so much everybody for joining us, and hopefully we know you're around the world. So obviously there's only you'll be able to watch some bits, maybe not the other bits. You're probably not going to stay here for the whole thing. That's totally cool, because I mean, if you're Nick and you're based in Singapore, you're not probably going to want to be staying up until 3 in the morning. I mean, I don't know. Some of you might. no. But probably think something to mention here is that has been the trend for the past 15 months. A lot of conferences have been pre-recorded, and there's a really good reason for that, because obviously you've got speakers from around the world, and there's various sort of there might be some technology challenges, that kind of thing. But we've decided this year we're going to go live, so the vast majority of our talks this year will be delivered live. So our speakers will be tuning in. We've got some speakers getting up quite early and some speakers staying up quite late for some of these talks. But the vast majority of these talks are live. And the other thing we're doing that's a little bit different is we're going to be a bit more conferencey, as in, I think the sort of like the grouping on demand things works really well when you had in-person conferences as well as your sort of online conferences. But given that pretty much everything's been online over the past 15 months, we've got a bit different. So we've got 5 tracks, and each track you can kind of treat them like TV channels. So you don't have to click and select another talk once one talk is finished in the track. You literally just sit there, and they're just going to keep streaming. So you're going to have to keep the talk streaming, which is nice. We've put in chunkier breaks as well for you. So you've got a good, you'll always have 10, 15 minute break between two to 3 talks, where if you need to grab a snack, if you need a break, you want to quickly stretch your legs, you want to chat with your fellow conference goers and discuss any talks or build those new connections, because we're all about new connections. So you want to reach out to members of the Neo4j community, you've got that option there. And the other thing as well we're doing, which is super cool, is we're doing these panel conversations. So, historically, you have a talk and then you have the Q&A at the end of the talk. What we're doing, which is slightly different, is you have 2 talks back to back, and then we have an extended Q&A and panel conversation. So what's going to happen is you're going to have the speakers from both talks together with a moderator, and they're going to be answering all of the questions that you're putting forward. So all of the questions you're asking about their talks, they're going to be discussing. They may bring their own questions as well. And it's always fun when speakers ask each other questions. So you're going to have that interaction as well. So all of that is going on. So that's super cool. I'm very excited about that. So just wanted to quickly put that in there as well. So a little bit different.
No, but that's great. I think it really makes a difference. Like Kim already said in chat, you can watch on demand, but it's live is live, and that's always it makes a difference, and it feels different, I think. I just wanted to say today is going to be a hot day, at least in some parts of Europe. So if you are watching this all, and like Lou already did it, and I'm doing it now, hydrate. It's important. So if there is a break, grab your glass of water and just drink some.
Absolutely. So that's a bit about nodes. Yes. So a couple other things.
What else should we know about nodes?
Yes. So we have a closing keynote this year. So we didn't have like an official one per se last year, but we do this year, and I'm really excited about this. I don't want to say too much about it. But it's fun, and it involves our amazing Neo4j community, and that's what I'm saying. But stay tuned.
Stay tuned. Exactly. That's a good teaser. It's gonna be good. Jim Weber is basically hosting it, and whatever he's doing is always great. So I'm looking forward to him, especially because it's gonna be fun.
Yeah, and I totally know for some of you that's just going to be way too late. That's fine. You'll be able to catch up. So that's something to mention as well. And Kim puts in a very good point. So yes, we've got 5 tracks. So we've tried to slim down the number of tracks this year. We've tried to space the talks a bit better. So hopefully you're not going to have too much sort of FOMO going out with the live talks. But if there are clashes, if you know what, you don't fancy staying up until 2 in the morning, you will be able to catch up with the content, so you won't lose out. So I've got a question here from Colston asking, if people can't see the sessions live, how quickly will be available on demand? I believe I need to double check. So I will see if we can find out your date. But I think it will be a few hours afterwards you'll be able to catch up. So it's not like you're going to have to wait for weeks and weeks on end. It should be available pretty soon. I think we're talking hours, not days, not weeks. I think we're talking hours. So pretty quickly that will be available. And then I think we'll be like the individual videos, so rather than watch them as one giant stream, individual videos will be available soon after, like a few days of processing. And obviously at some point in the future, they'll all be available on our YouTube channel as well. So they will be there. Don't panic. Just make sure you've registered for Node, and then you'll be able to get that on demand.
Exactly. If you once you register, even if you can't make it later today for some reason or other, and then you will get a link once the recordings are published, and then you'll be one of the first people to actually know where to go and what to click to watch them. Yeah. So yeah, do register even if you can't make it.
Yeah, right. I realize we've got 2 minutes. We better rattle through quickly. Yes.
Yeah.
So very quickly, shout out to our community partners. So these are going to be our moderators for the session. So
we had this last year, and I think it was great. So various communities around the Neo4j wider ecosystem come together, support us here with the tracks, do some introductions of speakers, show who they are and what they do, and it's really a nice insight into the community as well. You learn about the community as well, but also get some details on the speakers. So I think it's a great way. And then the first track basically is the Neo4j track, which we have set out here. So you can obviously check out the agenda in full detail, and we will go through each track in detail a little bit throughout this morning show here. But you will see everything of course on the website. And here are a couple of classics on Neo4j, as well as new content. Really, I mean, everything will be new, but an introduction to Neo4j is a classic. That's what I mean, right? We have these everywhere, but still some new things. Excited. So especially what's new with Neo4j 4.3. I think that's going to be interesting because 4.3 will be released soon. As well as Graph Data Science 1.6, what's new. So these two are really diehard Neo4j product news. So what's going on with Neo4j at the database and the Graph Data Science library. So these will be very exciting sessions on the product itself. But then also you can see here other things around Neo4j. For example, Neo4j and GraphQL, the past, the present, and the future. I think that's done by Will. On GraphQL, which now has a proper driver released since last month, something like that.
Yeah.
So it's really also a brand new addition. And then another one that is something we use a lot here on the streams is the Arrows app, and drawing and creating graph with the Arrows app is another session we have here. And then we have the possibility here to check this out. It's this great tool. I think Arrows is great. We have done it a couple of times in the streams. It's very easy to get going with that.
And what's probably worth mentioning here quickly. So you'll notice we've got 5 tracks. We've got the Neo4j track, the data science track, the visualization track, apps and APIs, and best practice. And what we've done this year slightly differently is we've tried to put everything that's about sort of product updates or anything that's really literally just Neo4j centric. We've popped them into the Neo4j track. So everything else is all about things that people have built out, things in productions, their experiences, lessons learned, that kind of thing. So this is very much focused on the Neo4j stuff. So all of the other things split out on the other side. These are all like, this is what the community have been building. These are tools the community have been built. I mean, we've got examples of people who've built sort of various frameworks and drivers and things to work with Neo4j. So all good stuff there. But yeah, brilliant. Looking forward to it.
Exactly. Yeah. And with that, I think we have our first guest in the show. So let me switch this off and slide this one in. Welcome, Priya.
Hey, hello, Alex. Hello, Lou.
Good morning to you.
Good morning. Good morning.
How are you? How have you been keeping?
Oh, I'm good. How about you?
Oh, all good. All good.
Busy. Totally busy. I can see that. And you started pretty early and you have a long day ahead of you. So yeah, keep it there, keep the energy in and going.
Yes. So some things have changed between the last time we spoke.
Oh, yeah.
Would you like to tell us a bit about it for some of the people who were also watching last year and maybe?
Yeah, let me set the confusion right there. So yeah, it's first of all, I would say that I'm really happy to be back once again. I didn't think it would be this soon, but nevertheless, yeah. But there's been a little bit of role reversal now. So last year, I was here at the keynote show as a guest, and today I speak in the capacity of a Neo4j node myself. So it's been it's been a long journey since then to now, and super excited to be here, in your company, doing this again. So so there's been a transition there, right? You're right, Lou.
That's great. It's great. We're super to have you on the team and to have you join us. So and then super great that you join us again after last year. So must mean something. You must have liked it.
Oh yeah, I think it's this is the whole journey with Neo4j that I started off as a customer, and and then it kind of just brought me here to Neo4j. So it's been incredible, and really thankful for it, for the opportunity. So yeah, so that's it. We have an event ahead of us. So how are we doing there with the event?
Yeah, no, it's going great. We have I think we can share that we have over 10,000 registrations so far.
Wow.
So it's really going well.
Amazing.
And the numbers are growing still until basically the keynote kickoff later today. So lots of exciting tracks. We just went through the Neo4j track.
Yeah.
Do you have a personal highlight you're looking forward to? Besides the keynote, maybe?
Yeah, I think we're all looking forward to Emil's keynote.
Yes.
It's going to be the most exciting, start to the event. But that said, yes, I have made my own notes because we have an exciting lineup of sessions, and all thanks to the speakers that we got to talk at the event today. So I'm looking forward to a lot of sessions, and I hope I'll be able to catch them live. But nevertheless, some really exciting sessions in the areas of AI. I came across one where we're going to be talking about virtual humans, engaging in compelling human conversations. I really don't know what that is, and totally looking forward to all the wizardry that it has to do with. Then there's one on visualization, and I think it has caught the attention of a lot of people out there around virtual reality. It's about getting into the graph and visualizing it from, in a 3D perspective from inside. I really don't know what that is. Totally looking forward to that talk. And then, of course, there's a lot of sessions around GraphQL, and of course, we've just productized our own library around GraphQL. So we have talks internally. But that said, I think there's also one by an external speaker, Arif, who's going to talk us through the Hot Chocolate framework for .NET. I think that's going to be super exciting for .NET developers. And then, of course, around the whole area of knowledge graphs and search, I came across this one by Ashley, and she's like almost I would say a constant support for us when it comes to knowledge graphs. She's always talking and blogging about knowledge graphs, and she has one interesting session around equitable search. So I'm looking forward to that one as well. And then, of course, we have the usual suspects. So I think Tomas Pratnik is going to be there talking about NLP and graphs. And he's again, I would say, a champion for Neo4j, always blogging, talking about new features, in Neo4j, and totally looking forward to that as well. So yeah, we have like a real cool lineup of sessions, and thanks to both of you for making sure that we pick the best out of the lot. It's really, I'm sure there's just so much more. And of course, like you already covered the internal track on Neo4j, we have our own speakers talking about all the new features and new product releases around Neo4j itself. Then, of course, we have GDS, a new release, Bloom, again, a new release there. So lots of exciting things to look forward to. So it's going to be amazing.
Absolutely. And it's probably worth mentioning as well. So I don't know if we've got a few new people here who have, maybe you've seen this graph database thing, you've heard the word Neo4j, you go on then, I'm going to sign up to this conference. I'm not entirely sure what graph databases or Neo4j is. What would one, Priya, what would you suggest they should do if they are completely brand new? What session should they go and see?
Oh, totally. They should come to my session on Introduction to Neo4j, and I'll be doing it with Tom Heerens from the Neo4j EMEA field team. And it's one session that you ought to attend if you know nothing about Neo4j. So please do come to it and hear us talk about it. It's a whirlwind session, just 30 minutes flat, but we're going to take you on a trip. So yeah, so that's also something.
Absolutely. And yeah, so this is going to really set you up for the rest of the conference. So
yeah,
you're not necessarily going to be a Neo4j ninja. You will have the building blocks. You'll understand what a graph database is, what Neo4j is, and what is, where is all this hype coming from? Why do we all get so excited when we start talking about graph databases and Neo4j? So yeah, absolutely. That is the talk to go to get you set up, to get you ready for the rest of the conference.
Absolutely. Yes. We're going to have some fun there in that talk, I promise you.
Is there anything anyone should do, like pre-session, to get themselves ready? Is there any advice you would provide?
No, I think you should just keep the rest of your day free. Make sure that, and you wrote a blog on that, Lou, make yourself comfortable, take a comfortable position wherever you are, and stay tuned, stay glued, and just enjoy, sit back and relax and listen and tune in. So, it's important to keep your day free. So if you're at work, make sure that you wind up early so that you have the rest of the day ahead with you. So yeah, but then it's an exciting day, and I think if you can be part of it, you should. But nevertheless, you can always catch the recordings later in the day if you can't make it. But we'll just be happy to have people tune in. So yeah, definitely.
Absolutely. Just wondering if we can sneak. I'm going to sneak another one in. So we've been doing this a lot.
Away.
So I'm always doing it. You know what? You all know what I'm like. What can I say? But so Will and I have been doing a series of podcasts. So for those of you who are interested, that's graphstuff.fm. But we've been interviewing a few people who are doing talks today, and we've just been talking to them. And one question that we've all been asking them is, what are they excited about in the future with respect to graphs? So I'm going to ask you, what are you excited about graphs in the future?
I don't know. I think when I look at the product and this very amazing technology that we have with us, I think the possibilities are limitless. We already see customers and the community at large putting the product to use in unimaginable ways. And I think for me, that's the most exciting part of being, part of Neo4j, to just, be part of those customer experiences and, the different implementations, realizing the true potential of what you're trying to do, what you're trying to solve for using the products. So I think, I don't know, but I think it's an exciting phase ahead of us, and it's only going to get exciting with time. I think graph technology is picking up at a pace that we've never seen before. And the next decade definitely belongs to graph. So I think it's going to be a super, super exciting journey ahead of us for all of us, not just part of Neo4j, but just the entire community at large. So yeah, Lou, I think that's something to look forward to and be part of it, most importantly. Yeah. Right.
Super. Well, I thank you very much, Priya. I think this is us for the moment. Thank you for joining. Thank you for giving us your highlights of notes. So I think there are a couple of great sessions in. So if you all look for inspiration, that is good to I think some good pointers. And yeah, hopefully we see you next time again on another stream or somewhere else. So good luck with your talk for sure later today, and see you again soon.
Thank you so much, and have a great rest of the day, both of you. And yeah, and keep that going. Keep it going. Thank you.
Thank you.
Yeah.
Bye. See you later.
Super. That is cool. With that, I think we are at time to show our first, Remembering Notes 2020 restream, where we have Polly Wong's broadcast on the workshop that the graph database workshop that changed the industry. So that was her session from last year. We will watch that together now, and afterwards. We are looking forward to welcome her on stream live to discuss, about herself, what she's doing in the meanwhile, and about her projects on Graph or with graphs.
And it's probably worth quickly sneaking in. So we're all going to be watching the video together, and she's joining us afterwards. So if you've got any questions, pop them in the chat. We might be able to sneak some of your questions in about the talk. So.
Okay, let me pull that up, and we'll see you on the other side. But obviously, we will be in chat. So if you have anything, ping us there. Enjoy, have fun with that session.
Thank you for the wonderful introduction. So today, I'm going to share with you an experience that I had last year in a workshop that I hosted and taught a bunch of students that are adults about graph database. Now, what's more important to know about this workshop is what we are trying to do. Imagine this. You are in an industry that is desperately needing to change. It's going to morph into something else, but you don't know exactly what it's going to turn into yet. And this is the story about that. So to change the title, instead of changed, we are changing, and it will probably always be ever changing. A little bit about me. My name is Polly Wong. I am the CEO of ViewSpace. It's a technology company that creates software for interior design and architecture companies. I am also the co-founder of an interior design and architecture company called We Create Group. You will learn more about me throughout this session, but what's more important is that I have come from a computer science background, merged into an interior design and architecture background with a huge interest in human beings and systems and how everything interconnects and how everything works together. You'll be able to find me at polly@gmail.com and all of the social medias that you could find through Polly Wong. Now, a little bit of a background about our industry, which is interior design and architecture, is that it is little known that it is actually a very money-heavy industry. What that means is that everything that you need to build, whether it's a home or a restaurant or a or a hospital, everything costs money. And within that, there's multiple structures, meaning that there's, from the homeowner or the property owner, you have the architect, you have designers, you have contractors, you have subcontractors, you have engineers, and all of the above. So what that means is that it is a vastly complex industry that holds a lot of, that are very, very, they have to communicate with each other very frequently. So with that said, how does the industry work? So when someone comes to you as a designer, they would come to you and say, I need this and that in my home or this and that in my restaurant. You, as a professional, you have to gather site requirements, you have to gather all the people requirements, you have to gather all the legal, local building code requirements. So all this information, all this data needs to be not only transferred real-time communication to a system-wide real-time, but it also needs to be compiled into usable information, from data to information, and be able to allow whoever that is driving the information flow to make reasonable decisions on a very expensive project. What that means is that the data structure is extremely important, because when the data structure is not flexible and it's not quick enough, then any bottleneck will basically snowball into a very expensive mistake. And in the industry, we call those mistakes change orders. What that means is that whether it's the homeowner changed their mind about something and they want to add something, we call that a change order. But if it was something that got miscommunicated or non-communicated, that also ends up to be a change order. So if we go back to the previous slide, change order, the number of change orders adds up to be about 33% of every single project on average. What that means is that if we could save 33% of that project, you basically earned yourself a $406 billion paycheck. So this is a very urgent and important and old problem that we need to solve. When was the last time you actually heard that a construction project was on time and on budget? Probably never, because it's very complex. And there's a reason why this problem has not been solved even till now. These are the tools that we're, as professionals, are dealing with. There's maybe 7 to 11 different file formats. There are different ways of compiling information. Say the financial department needs Excel sheets, while all that same information is being displayed in a 3D model on the architect side or on the engineer side. And say if someone changes the flooring material, the budget needs to change along with it. And that has historically been very difficult to sync up. So now we know that there's definitely like a structure problem. How does a project from start to finish work? The first thing you would do is you would first find the client. Second, as we said, we need to gather the site information. So you do a site survey, you do measure, photography, and all that. The third thing you need to do is collect the people information. The fourth thing you need to do is design. It's supposed to be fun. The fifth step is the construction and what we call documentation and construction document and administration. So this is where a lot of the project management happens. And if you need to develop some drawings for the building department, then you need to create drawings. If you need to, arrange your budget, you need to do this here. You need to put in orders for your items. This is where you do it. And then lastly, you would do the construction. And this is when designers would like get a lot of phone calls that there's a lot of backtracking information and or miscommunication would happen mostly at this step. And then the last step would be staging, installation, and basically cleaning up the edges, and hopefully you will have a happy delivery. Now, this is in theory. In real life, it actually happens all simultaneously. And as you could see, there's going to be multiple problems along the way that people just can't trace back where the problem came from. So whether the problem came from site survey step number 2, or the problem came from step number 3, where someone actually thought the homeowner said this and they documented it differently, or whether it came from construction. That happens all the time, because when you open up the walls or open up the floors, you see something differently. You make a decision on the spot, probably with the homeowner. The architect doesn't know, therefore the budget changes. No one could trace back to the problem. So it becomes a project management nightmare. It really does. And that is why we desperately need a data storage solution that allows for this extremely complex and time-wise intertwining system. Neo4j happens to be very good at that. Now, we haven't got into the workshop part yet, but these are the real pain points that we're trying to solve. One is miscommunication and non-communication. The other one is inaccessibility. And this has a reason why traditionally, historically, our industry, interior design and architecture, stem from a very, I should say, academic and top-down structure, power structure, which means basically whoever has the money and the power gets to do all these things. It's only been recently that democracy exists. And so, you know, if you think about it, now we as the people, and that includes all the professionals and all the property owners, and even people that are just thinking about doing things with their houses and their businesses, that we have the opportunity to own information when it's actually being produced. So inaccessibility has been an inherited problem historically. Third, because of the first 2 problems, there's a lot of redundant work. Usually someone, from step 2 didn't know that step 3 did some work that step 2 could do. So anyway, there's a lot of repeated work that happens because of miscommunication, and because this disconnect between members basically inhibits our ability to learn as a industry as a whole. So what that means is we're recreating the wheels all the time, every project. And every company that happens to start developing their own little library or their own little method of doing things, they try to keep it within themselves as a corporate or as an individual. And that creates a lot of silos. So these cross industries, sub-industry, meaning architects and contractors, these different arms of the same project aren't learning from each other and aren't building on top of this collective knowledge. And therefore, there's a lot of redundant work. Fourth, all of the above creates a lot of waste in time, in money, which is the 5th point. And then the 6th point is distrust. And that is the harm that has been done throughout 400,000 to 600,000 years of building history, that we have always had difficulty managing project in communication and managing time and managing money. So that creates a lot of distrust within the industry. And there are solutions. It's a mix of multiple things, and VR AR happens to be a very good solution because you're communicating with visuals in 3D, and you're allowing people to be in the design, and then the other solutions that we mentioned above. But what is really not mentioned here is that within these 6 solutions, there's a fundamental foundation that needs to happen first, and that is data structure. How do we organize our data structure, and how do we build a team or multiple teams that could grow with the data structure and grow with the unknown of the industry and how it's progressing? Because I have a feeling that architecture and interior design is going to turn into some other type of industry, or would look a lot different than what we have now. And these could be micro teams within multiple organizations or within the same organization. And I think everything is going to be broken down into a very diverse, but sort of everything will be democratized. And that's a fundamental change that's going to happen. So why Neo4j? We need 3 things. One is intuitiveness. This is hardly, I think most graph databases have this, but not many could do it to this level. I think if you could draw a bubble diagram on a whiteboard, you could draw it in Neo4j. And that has been really valuable for us, because now we're actually needing to teach architects about Neo4j. Which architect needs to learn databases before they start doing their construction drawing? They historically didn't have to, but now we're teaching them a new language. And the easiest that language is, the higher the possibility that the whole solution will work, because we need it to be simple, to be human language and not computer language. The second thing we need from Neo4j, which has been proven to be very effective, is speed. So what you see here is the comparison between relational model and graph model. And this is, without reading it out to you, I think anyone that has tried Neo4j before knows that speed and has been a really great thing from Neo4j. So what does intuitiveness and speed add up to? It just adds up to agility. So reason being, we are a mega industry holding a lot of sub-industries that are in the process of great change. And this change, the direction of this change is unclear yet. No one really knows. I mean, everyone could guess that where this industry is going to head to, or their own sub-industry is going to head to, but no one truly knows where it's going to become. The carriage industry never knew that they're going to become obsolete when the car industry came about. All the horse barns just go out of business. So what I'm trying to get to is that it's extremely important that not only the system needs to be right, but the meta system also needs to be right. And Neo4j, fortunately, allows us to do that. This is a general picture of our stack. Basically, it concurs with Neo4j, GraphQL, and Vue.js built on top of the Google servers. Now, I think this, up to this point, it's fairly easy for people to understand why we're doing this and just, generally how we're doing this. But this is truly, one is from an industry level, and then the other one is from a system level. When you look at a team like this, how do you deploy a very new team to create a new culture and create a new way of working? So we're finally getting into the workshop. So we decided to build something called Jita. And Jita basically is an open source code base that allows us to create a tool to solve that problem that we just mentioned. So this experiment really started from a little island called Taiwan, and it started from a conference called the Open Up Summit. And about the Open Up Summit in 2019, there were some special things about it. It came from speakers and attendees came from 9 different countries. We were talking about 4 different open tracks: open design, open source, and open other things. And what was the 2 most special things is it crosses a lot of different industries, which means that people that come here are trying to solve problems that are cross industries. So lastly, what was really, really great about it is that the female and male ratio is 55% to 45%. Anyone that has attended a tech conference knows that this is almost impossible to have more female attendees than male attendees, which is not to say that that's more important, but it is to say that it is extremely rare, and I think that calls for a shout out. So this is what the workshop actually looked like. It was not, we limited it to a certain amount of people, and as you could see here, that there's more, I would say it's generally more female than male, and it was a 2-month-long workshop. Everyone here are from different walks of life and different industries coming in and have a little bit of coding background, but we taught from scratch on what is GraphQL, what is graph database, and what is Neo4j, and we walk them through, eventually leading them to a point where they're able to contribute into this solution that we're creating called JITA. So these are just some pictures, and this is part of the conference attendees. The conference was 2 days, and we gathered all these people from around the world and had a really, really great time. What did we learn? So upgrading an industry is extremely hard because you're trying to paint a picture to multiple types of people, and that picture isn't completely clear yet. So when the industry itself is being redefined, how do you upgrade that? We start from, instead of coming up with the right answers, you need to ask the right questions first. So when every evolution starts with the necessity to grow, I think the most important thing when we started is to draw a vision, and that vision could look like anything, but these are the problems that we need to solve. What interior design means to me, and this comes down to like in the very individual level, it's very important to go from small scale to a large scale because people will easily get overwhelmed by solving too big of a problem. And so what they need to do is they need to imagine themselves in this context, and what does that mean to me? And then what does that mean to the industry? And what does that mean to society? And this is something that historically, although architecture covers a little bit, but we have a very different way of looking at society right now, and we have a different way of processing information now. So what does interior design or architecture or fill in the gap means to society? And what does that mean to the human race? Why do we even need to ask that question? It's because if we do this right, that means this problem that we're trying to solve will also being deployed perhaps out of space, perhaps on the moon, right? So everywhere that has space will probably require us thinking about it now to solve that problem because we're actually in the space age now. Second thing is every revolution starts from the bottom up. And that, if we start, and now we're talking about system and data, you have to start from data or the data of data. And that basically means that we have to train this team of designers, architects, and contractors and engineers to start thinking about data differently. And they need to start understanding how everything interconnects. And that is why the second point is the connection is more important than the data, because the data is always going to change, but the connection structure is arguably more important. The third thing is you have to start local deploy local, meaning that it almost needs to be a microorganism first, and then you need to deploy it everywhere. And that organism needs to be living and be bred into a very diverse environment. What that means is that we have to steer away from a very sort of monoculture. The third point is to have it be borderless. What that means is that we need to have globalization in mind when we design this new system. To picture the evolution will have so many micro evolutions inside. So in order to deploy or create a team like this, you have to allow the members to be aware of this culture. The more diversity, the more sustainable this whole system is going to be. Lastly, what we really, really want is to allow for these different industry of teams and different purposes. Everyone wants different things, need to be able to cross-pollinate freely. And what I'm talking about is the knowledge, the data, and the way of working. I want to end with a quote from Alvin Toffler. The literate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. And I believe that Neo4j allows us to flexibly and affordably do those things quickly. Thank you. And you'll be able to find me here. And thank you for your time.
That was super cool.
That was great. And here we go.
Hey.
Hello.
Hello.
Good morning. Good morning.
Good morning. Yes, it's so great to have you. I'm really sorry for everybody that doesn't know. It's ungodly early for Polly. It's really, really early. What time is it again, Polly?
Right now it is 4:10.
Wow. Yeah. See, it's crazy. But nevertheless, thank you so much for joining us at 4 a.m. in the morning.
It's such a pleasure.
Yeah. It's and in your talk from last year was really great. So it's super to see you here live with us now. A quick word about you. So you are the co-founder and CEO of JITA, Just-in-Time Architecture, you gave a talk about the workshop on it from the session in a conference in 2019. In notes last year. So maybe we take the time and you give us a quick, update on what's next for JITA, what happened between the presentation at Notes last year and now in June 2021.
Thanks for having me. First of all, it's such a pleasure to be here. I think it was really great to sort of follow up on see how far we've come in a year, really, as a startup. Today, we've launched a product, and it's an app product.
Cool.
Everyone could go to jita.io to check out the site that we're open to. Well, we're open limitedly in a beta testing right now. So what we're doing is really creating, if you imagine in software design, when you do QA, quality assurance, there's like this element where you have to do end-to-end testing, right? So we're adapting these software design practices into architecture. So what we want to allow customers to do is be able to scan their room within their phone, and then have, with the pandemic and everything that sort of came about was very useful. And then now we're able to organize a lot of that communication data using Neo4j and create a bunch of task lists, milestones, allowing designers and architects and contractors, especially the homeowners, to follow through the project development and design, as well as building, through this Jita system, and really just on the tap of your phone. So it's really exciting to see how cute we were back then.
No, it's great, and congratulations to launching your app. I mean, that is super good. I just posted the link in chat, so everybody who wants to check it out, go to jita.io. Is it available for download for everybody, or do you need to enlist in some kind of registration beta?
Right now, we're sort of on the verge of, not yet, but yes, but we're definitely a lot closer to having a product than before, which is pretty much testing out with the community and also the open source community mostly, and that's been really interesting. I think being in a community where it's always been very commercialized and expensive, and we're going open source. Flip the table. We'll see how it goes.
Super. Good luck for sure. It's great.
You.
So, what I'm quite curious about, so I'm going to have to apologize for my complete ignorance in the sector that is all things architecture from building perspective. So I guess the interesting thing here, because I've always sort of thought about when you're building something, when you're going off, you're going to go build a building, and then you're going to be thinking about, well, okay, you kind of want to try and put as many parallel streams in possible. You don't really want to wait for one thing to happen before you can trigger over the next process. And I've always sort of thought that this kind of thing must be very sort of like, if you think about project management, it's always this sort of waterfall planning, and you talked a lot in your presentation about change management. I think that's what, I've always known it's change management, and change management is bad. You want to do as minimum amount of change as possible, because the more change you do, the more it costs you. And it's kind of interesting because you have those two patterns, don't you, where you have your classical waterfall project management process, and then you've got in software moving more, and basically it's probably the de facto standards more your agile software, so agile project management, and obviously pros and cons. What I'd love to know, and I think sort of obviously Jita is trying to do this as well, is how have you found it? Has this allowed you, this processing or the thinking process, does it give you that dynamic situation so you can leave that? What's been the experience like?
One of the things that we needed to address first and foremost was the problem is big, but the solution really needs to be solved from bottom up. It can't be solved from top down, meaning that the end, whoever pays for the product needs to be the driver for the whole chain of production. Basically they need to own the project, and with that they could sort of push for change and use a system like Jita. And that's the homeowner, most likely the homeowner, business owner, whoever that's paying the bills. Now, they've always been very scared of signing any sort of contract, because that's like signing your life away and you can't change. And that's really not realistic at all. So what we've done is we've built on top, well, I shouldn't say on top of, but sort of in tandem with Neo4j, we also have a Hyperledger blockchain that's built side by side. So with that, with blockchain, you have smart contracts, right? Now, every single agreement, minor agreement, like smallest agreement, like we're going to have a meeting on Sunday at 10 a.m. And then someone's agree, and then and then they all show up. They happen to, they have the meeting. So that is a micro agreement. I see that as a micro contract. What we've been doing is we've been breaking up this ginormous contract into a gazillion micro contracts, which in project management world, you see them as tasks, accomplished tasks, checked, right? Moving on to the next one. And what that means is it breaks up this structure. It allows for agile I don't think the terminology works for, everyday homeowner. You would imagine like, a 65-year-old, retired, something. No, they're not going to learn that. But what they do like is that they don't have to sign their life away. They're just agreeing on a very small thing, tiny steps at a time, and everyone agrees, and then that's a contract. That's a process done, and then so the way a little bit on the back end is we store everything in both Neo4j and Hyperledger. Most of the tracking we do, or the request comes and gets executed from the blockchain end, because a lot of people wants to track what happened, when, and why, and then what needs to happen later. All that. What Neo4j has been really valuable for us is analysis. After it's so easy to see, zoomed out, looking at the graph of patterns, behavior patterns of people, very real people. And sometimes it's the task that happens between people. Sometimes it's the object or files or information that's being exchanged. And a lot funny thing, architecture has been talking a lot about this thing called, it's a fancy term now, it's called digital twin. Basically, it's like Second Life, but in architecture. So you want to, right. And that's, that is useful for some reasons, but it's really fancy. It's a little bit of a, right. It's a fancy term. So what they're trying to do is simulate building process digitally so that they could save on costs. But what happens on the information level is that what we're trying to do is actually use, if Neo4j down the road could become the sort of the relationship structure of the physical world, meaning that, in physical world, we have gravity. How do we represent that information using a graph? That would be really, really interesting. How do we represent form, structure, the relationship between items? How do we go it, define it really down to the bolts and the concrete? Obviously, they have a connection if they're bolted together, right? You see what I mean? Like, so we're actually building the building on an information level in Neo4j. And what would that look like? That's sort of what would be really, really interesting. The next big thing, what I think could be the next big thing for both industries.
What's really fascinating about this, and that's something that's twigged in my head, is especially this idea that you're having to do an abstraction, aren't you? Because effectively you're going to have your different buildings, they're going to be built in a different way, they're going to have different setups. If we're going down to like the interiors, or even, actually, let's forget about the interiors, like where do you put doorways? How do you align things? And the really interesting thing here that sort of I thought was really fascinating, you talk about it, is the patterns. And I think when you have that abstraction and you now move away into the graph database, do you start to spot patterns? So is there a certain thing that physically, if you looked at two pictures of them, you'd go, yeah, they look different? But is there a subtle thing that's going on in there that you've missed some connection that basically says, actually, this is a pattern that keeps repeating? So like,
yes,
the distance between two doorways, even though you may have two doorways and there's a corner room, or you have two doorways and you've got a straight corridor, is there a pattern that just keeps happening over and over again? And I think even into your micro contracts thing, which is quite interesting, is there a set assumption in the construction industry where you go, well, this chunk of thing always happens, but now that you're involving the person who's paying for this, is there a pattern that keeps repeating over and over again, where they go, well, actually, these are the tasks and these are the orders that 95% of them want to do when you do split it down? Does that now change the thinking about what kind of thing you present in the future, it's really fascinating. Like, so cool. I mean, has stuff like that been coming up?
What has been really interesting is that traditionally we would think that you need sample data in order to observe pattern, and that certainly has happened. In building, because we have all these local regulations on building codes, now we're trying to see if we could define a graph, to some extent of detail, treat it like a template of some sort, like say, okay, this is the building legal laws, sort of logic, if you will, of Brooklyn, New York. This is you could do this, you can't do that. The distance between the front door and the back door needs to be this. The fire escape needs to be like that. If we define, we haven't gone to that deep yet, but that's certainly our next step to explore is when we do experiment with these things, does it match up with reality? Is it actually effective? And that just goes to say how flexible Neo4j is, because it's simply a node and a link, 2 nodes and a link, or a single node. All we want to do really is to communicate. And communication, if done well, means transparency and work being done. And eventually money being saved and time. And hopefully they get to move into their home sooner, right? So I think we have the distinct privilege to really be invited into people's homes and sort of invite them to join this journey of data. I would say we're still exploring. We're definitely still exploring the depths of how this could be and how complex we could get, because who knows, maybe we hit a wall. But so far we've been having a lot of fun just to see the digital representation of what's actually happening between the links and relationships and through time for people doing something very, very personal to their lives.
No, absolutely. No, super cool. Super cool. Oh my goodness. I could talk, I would love to talk about this for hours. I think it's so fascinating. So I guess what have been some quick wins that you can think of that have come in? So anything that springs to mind as you've been going through this journey? Because obviously you've been building the app, and obviously the goal of this is you want to have something that is highly automated, low manual involvement, so that the fact that you're doing that. But I'm kind of going to assume here that what you've been doing is you've been using the graph element and the blockchain element as helping you through this manual process of walking things through and seeing what's happening. So what interesting discoveries have you spotted? Like, is there an example project that springs to mind? And what did it look like?
What really is, I guess, while we're testing with, real people and all that, and that's been fun. Not a lot of times you could involve with people that most of the time have no concept of technology. A lot of times we need to teach them how to copy and paste something on a computer, and then expand their openness to information on your phone. So, and I think that's really exciting on a human level. What I think infrastructure wise, again, we're sort of building almost the operating system, or rather the protocols that's happening, HTTP protocols, down to that the beginning of architecture, sort of digitization, I would say. We've tried to do 3D, we've tried to do a lot of other things that are not really solving the infrastructure problem in information and obviously business structure. So me and another company called Speckle Systems, their role involving in data reform in architecture is they're doing sort of a version control Git. They're sort of like the Git and the Jenkins plus Docker of architecture information, and we're sort of like the Jira plus end-to-end testing, sort of the user end of things, and that's been, I think, I really adore that process. Thank you. That's my cat. So I think what fascinates me is the volume of things that we need to learn internally and externally and between us, and then building a building or building a room or a bathroom is really just sort of the way we connect. I think Neo4j has been really friendly for them, for most people involved, and a lot of times we don't really have to involve them. But as far as like if the internal team, we definitely had a little learning curve there. But it was very easy to overcome. It's like when people just start learning coding, they would either gravitate towards PHP or HTML. Definitely not Java. So, when they just start. So, when it's easy to learn, then, you invite this whole demographic of people that don't normally get involved. And that, that is priceless. You're teaching, allowing them to go into another world.
Super cool.
Yeah.
Super cool.
That is cool. I mean, maybe one last question, if you still have time. Do you have maybe some kind of predictions on the future of graph database technology? For you hinted at a couple of things for interior design, but is it? Do you see like a like you walk around an app with the app, and then you scan a room, and then you transfer it directly into a blueprint, and then it goes into your and you say, hey, I'm building a house, and I want this bathroom from there, and this living room from here, and this doorway from there, and then put it all together in like a builder, and then send it over to your construction company and say, here you go, this is what I want.
Hands off. Yeah. No, I think like it would. For the future, the digital twin thing, I think, could be expanded in a very, very deep extent to the physics and the chemistry and everything that we have in the real world. We should be able to represent that in Neo4j, I believe. We just need to do it, and we need to do it sort of little by little, and then we'll see how the minute changes in the real world and how that's being represented in a graph, and observe and hopefully learn from that. That's one of the possibilities that I think very likely will happen with multiple forces sort of converging right now. So whoever that wants to talk about that, reach this address, the email. So or I think breaking contracts down into micro contracts, this concept could be utilized in many, many other places. Anywhere where you find it very hard to commit, where people have committing issues, that's where a micro contract will be very, very valuable. Really, it's just allowing people to not have to fit the system, but the system fit the people, because you're breaking it down to bite-sized pieces. And that goes for not just contracts, agreements, but it also goes for government rules, I would say. I think, it's worth noting that democracy process over, across the world is complex and also being challenged greatly. And that's because there's a need for I guess, bringing it up to date, not the basic form of it, but it's sort of like the agreement structure, because we have a different way of absorbing and agreeing or disagreeing with information nowadays. And the time that it takes for someone to, information is just having a different speed development than the rest. People development is much, much faster nowadays. So I think Neo4j, if the corporate is smart, or the community is smart, maybe is we should involve a lot of, we should tap into that government agreements. And, for us, obviously it's building codes and all that stuff, but that could definitely be expanded into different realms of government and rules, and involve people a lot more. When you involve the people that get affected the most earlier in the process, they feel better. It's like when you're waiting for a train and you don't know when it's coming, you get anxieties. It's just normal. But if you're waiting for a train and you see the clock countdown, and you see where that train is now, is where it is now, and then where it's coming, when it's coming, how many stops away, you feel better and you're patient. It creates order, because now you're exposed to transparent information real time. And Neo4j really has the power to because it is so flexible and it is so agile, that and I would love, and this is like going beyond, I would love Neo4j to be completely open, because it almost is infrastructure. It is so important for people to be part of it and have no friction for adaptation. That it almost outweighs the I guess the other side. So, but that's on the level of human development, as a race, as cross-country global development. So yeah, that's my hope. That's not really a forecast, but that's my hope.
That's a great hope. Yeah, I think I totally agree. And I think, like you said, I think one of the pieces that stuck with me most is this bite size thing you just said. Is like, if you imagine you have a contract that is 20 pages and you have to sign on each page everything, and it's gonna be very hard, and you struggle with it probably, and you see, okay, well, I'm not sure I can commit to all of this. But if you say, okay, this is one step here, and I can, okay, this is I understand this piece, and check, and then next, and then, like you said, with the train, what's coming, what came before, what's coming next. It's a much more easier process and easier to understand for everybody involved, and everybody knows where they at. So that's also very helpful. So yeah, it's a great concept.
Yeah, allowing them to see like, potential bottleneck ahead, 3 steps ahead. Yeah. Wow, you get so amazed by their joy. Yeah.
Okay, well, thank you very much, Polly, for joining us. Sorry again that this was so early for you.
No, it's okay.
Really appreciate that you make the time. Lots of coffee, I hope.
Yes. And anyone that really wants to join the discussion or just be part of how we're progressing as an industry, feel free to reach out to me, either email or Twitter. I'm on there all the time, Facebook, all of these platforms. The more people are involved in the conversation, the better. That's my very provocative belief, where I do believe that a democratized communication flow is the inefficiency of that could be offset by the agility of our data structure now. Because a lot of times people would say that that's inefficient, but I do think the possible, the positive side of that could, it's so important, because trust is not existence in this world now. It's hard to measure trust. And I think if you could gain trust just by changing the way, this frequency and the sequence of which the members of this communication being presented and you're being involved, why can't we do that? I do think that that's what we need in all, not just building, just in everywhere.
Super. Again, thank you very much. I hope you enjoy Notes later today. And we'll hope to see you soon. And maybe, like Michael hinted at, maybe we do another stream together on Jita or your tool and see more in depth what's it all about. Thank you, Polly.
Thank you.
Have a wonderful day.
Have a great day.
Thank you.
Bye.
Bye.
Super cool. Super interesting.
Yeah, very, very much so. Yeah. Oh my goodness.
All right. Let's switch over to here the overview before we have our next session. So again, we'd like to remind you how to register. It's basically neo4j.com/notes. You can in Twitch you can type !notes. You get a link directly. Otherwise, this is probably not too difficult to type into your browsers and to register here. We have some tips and tricks or some suggestions how to make the conference more fun for you. Is use the chat tool, really reach out to people during the sessions, talk to everybody, ask questions, connect with other people, connect with the audience, see who else is online, share your thoughts, share not only where you're from, but maybe share what you think about the sessions. Remember, everything is live, so the speakers will see what you write. They will appreciate if you say, "Hey, this is cool. Thank you for sharing. This is interesting." And if you know, it's difficult. You still speak to a webcam, right? If you are, even if it's a live session. So if you get some feedback during a session, like for us here, if you write in chat, it's a great feedback. So we see, okay, people are watching, people are enjoying it, and if you have any feedback on what's to come here on Twitch, right, but also later in Notes, type it in the chat, and it's great.
And tweet if you're on social media. If there's a talk you're really excited about seeing, tweet about it. Please, we appreciate you do #Notes2021 on there as well. But if you see a talk that's excited, tweet it. If there's a speaker you're really looking forward to seeing, tweet it. Give it a shout out, because it's like that's something you put yourself into the shoes of the speaker. It's nice to know that people are looking forward to, or have enjoyed your talk, they've learned something new. So yeah, give them a shout out on social media, or on LinkedIn as well. I forgot about LinkedIn. Whatever your platform is, give them a shout out. But yeah,
exactly. We're on Discord, right? So again, this is also a possibility for you to chat and to interact with people. So again, on Twitch, !Discord for the link. Otherwise, dev.neo4j.com/chat, and you will go directly to the Discord, where we have dedicated Notes 2021 channels. So if you are on Discord and you join that server there, type in any channel you can !Notes, and then you will be unlocked to access the special Neo4j Notes 2021 channels, where we can then as well discuss with the community, even do audio chat and talk about what you heard in the sessions.
Indeed. Right, let's have a quick look at the next track before we jump into our next video. So
all right, so we did that. So that was just now. And next up we have Rajesh Gadipati, Scrape from Multiple Sources for Better Visualization, and Notes 2021 Revisited session. And afterwards we will have him as guest as well. Rajesh is senior application developer at Fujitsu Consulting India. So we will talk about his session, his work, and what he's doing now in roughly half an hour. And maybe before we go in there, we go into one more track that we have that consists of Notes 2021. So again, here are our community partners. Thank you very much to all of you here listed that make Notes a success as well. It's really great to have the community here around the developer landscape to help us out, because it's really a huge effort. And next track we want to focus on is the data science track.
Yes. So let's talk about. So as the name suggests, everything in here is about data science of various forms. So you will notice as well in some of the other tracks, we do have some other data science-y topics in the other tracks as well. So if you are here for the data science, don't forget to check the rest of the schedule too, just in case. So quickly, let's have a look at what's going on. So we've got a few knowledge graphs in the session today. So you've got the first session, which is going to be talking about how a knowledge graph was put together to fight against COVID. You've also got a sort of health knowledge graph built at scale, so what BASF had been doing, and that's also featuring Dataiku. So if you are into your ML data ops, that you've got a session on there talking about how that's being used as well. We've got a very popular rich one where graphs are used a lot for trying to detect dodgy behavior. So we've got a session in there as well. We have another ML ops based talk on the KNIME, I can never remember how to pronounce that, so do check that out as well. For those of you who are follow Tomasz Baratanec, that's, I think Priya was mentioning his talk earlier, so you've got the text to knowledge graph coming in. We have also got, this is going to quickly grab a few more. So if you are doing a lot of work with RDF and ontologies, we've got a session there as well using neo-semantics. So for those of you who are neo-semantic fans, you've got a session there as well. For those of you, we also are going to talk about how you can patch in Apache Spark into Neo4j. For those of you using that space, we've got an exciting new thing. So we touched on in the notes track that you've got a session on what's new in Graph Data Science Library. You're also going to have a session as well about doing the link prediction and deep dive in there as well. And one that sounds very exciting as well. So effectively analyzing your dreams using graph data science and graphs and graph databases. So exciting. So very super brief overview of that. And I guess we should now dive into the next video.
Yeah, maybe just one more thing on the BASF thing. It's a knowledge graph, and that consists of patient data of 5 billion nodes. So I think that is a significant amount of nodes. So it's a very large data set. So that is good to see how at such scale Neo4j is run and worked. So it's really good.
Absolutely.
All right. Yes. Thank you. Well, we now go into the next video from Rajesh, and we'll see you on the other side in about 25 minutes or so. Enjoy the video, and again, like last time, if you have any questions, anything for the speakers, please put them in chat. We will have Rajesh live on air basically in a moment, so he can answer your questions, or if you have any other comments, always welcome. Enjoy the video.
Hello all, good morning, good evening. So this is Rajesh, and welcome to my talk on scrape data from multiple sources for better visualizations. So this is the agenda for today's topic. So introduction, power of graph analytics, and we have two visualizations for COVID-19 spread across the continents and homonymous cities insights. So let's go ahead with the case one. But before going to that, I just want to give you the background of it. Like when we want to create any new visualization and your data set is not available ready, the options that we have is either we ingest the data from multiple URLs on web pages, or we create manual. So in that case, the web scraping tools, they are very helpful. Like we can pull any kind of data from internet database, like Wikimedia database we have, which can be mirrored But the only constraint that we have is like all the data is not available on a single web page, and it is not available in the same format. So in that case, we use some coding to identify the data patterns and we pull the data that is required for our visualization. Now let's see our first case. When we start the first case, like COVID-19 virus spread across the continents. So let's start with a question here now. On which date did most of the countries register their index case? So index case is nothing but the first registered case in any specific country. Now to identify that, we go a step-by-step process here, like ingest data from multiple wiki pages. Why multiple wiki pages here? Because Wikipedia has created a unique page for each and every country to understand, to get the details of that particular country situation in this pandemic. Like we have, for example, COVID-19 pandemic in Norway, COVID-19 pandemic in Estonia, these kind of unique pages we have for each and every country. Then we scrape the data from those web pages. For example, we take the required information for our visualization, then using Beautiful Soup, then we generate the Cypher queries automatically for a quick analysis. And then from this data, we can identify the answer to our question. So just to give you a background of the data patterns here. Now Infobox, which everybody knows here, like Infobox is something on every Wikipedia page where they give the complete details of all the attributes and values here. So in our case, for this visualization, so we need only the index case location and the arrival date. So that is one kind of pattern we are checking here. And the second thing is the timeline. So from the timeline section in every Wikipedia page, in every Wikipedia coronavirus this spread page, we need the preceding information, the preceding country information, like the virus transmission from one country to another. So for this, we find this information in the timeline section. So this should be done very carefully because the data validation is very important here, where we identify using some before keyword and afterward keyword search and all. So for example, countries with suffix. So there might be a traveler from one country to another. The suffixes of country are very important to identify here, like Indian, Iranian, or Chinese, Japanese. So these kind of validations we need. And one more important validation that we have done for this case is the predecessor arrival date should always be less than the successor arrival date. So which means that the source, the transmission from one country to another, the initial country's arrival date should always be less. So that's makes the logic here. So that's a very important validation that we have done. And the last but not least, the continent information. So we'll see in much more detail here. I'll just go and open a page here. So I'm just opening COVID-19 pandemic in Norway. So you can see on the right hand side, the info box, we have this index case and arrival date. So these information we require, because if you see our question is to identify the date on which most of the countries has registered their index cases. So we need this date information. So we are picking from here. And then comes to the timeline to understand the successor country, from which country the virus has transmitted to this country. Okay, particular country. Now we see the keyword searches, the major keywords like before keyword or after keyword or few country suffixes. We can identify the like returning from or a traveler with the countries with the suffix. So these kind of keywords we used here. Now you can see we are going for the timeline February 2020. So this is how we get the information of timeline. Now one more interesting pattern is the information what we require to prepare our visualization is continent information. So do we have continent information here on these pages? No, there is no continent information here. So we need to identify a pattern where for each country we need to get the continent information. So if we scroll down to the page, we have a section C also. In C also section, we can see COVID-19 pandemic in Europe. Norway is part of Europe. So this is how the unidentified data patterns here. We need to get the data pattern here to get information like this. And if we go for another country here, let's suppose check for Qatar here, we have the index case and arrival date here. At the same time, in the timeline from February 2020, we are just taking the information like the source, the predecessor country information we are picking up from here. Now, if we scroll down to the bottom at the C also section, we have the continent information, COVID-19 pandemic in Asia. Qatar belongs to Asia. So this is how we need to identify few data patterns where we don't get directly data sets. So now let's see, taking this information from these web pages. So we'll go to our code here. So these code available here. We written this code like we are importing 3 different libraries: Request, Beautiful Soup, and Wikipedia. And in the places.txt file, so this is where we are passing our arguments, like different multiple countries. We need the information for this. And if you see the directly functions here, where we are parsing this web page here, and we are pulling out the index case and the arrival date information from the info box. Okay, and then coming to the second function here, we are having we are identifying the predecessor country information by passing few keywords here in the countries.txt file. We are identifying the predecessor information. Now the last one, the see also section. In the see also section, we are getting the continent information. Now with all these values, we are scraping from multiple different web pages. At the end, we are building a cipher query. So let me execute the query for the time sake. So we can see, so in this query, we are having all the merge statements with all the variables from where we are calling, we are taking all the values and all. So finally, we get the output like this. So now I have passed only one country for the time being. So if we can pass 10 to 12 countries here, you can see this is the output we get here. Now let's take this output directly to our Neo4j and execute there. So here we have this query, same output what we got from the code. So I'm just executing this one. And now let's see the output for this thing. Okay, now when we see, this is the information we got from the query that we had generated from the Python code. So this is only for the 10-15 countries. So this doesn't give answer to our question. So to answer our question, we need the complete data set, right? So let's load the complete data set here. Now I'm just loading the entire data set from CSV here. Now we have the entire data set. So let's execute this query and see the complete information where we have the 6 continents information here with Asia, Australia, Africa. So I'm just placing it in an order here so that we can have a single glance of the entire spread. And here you can see the multiple clusters at the Europe from different countries here. So this is the entire cluster. And now why only you can see there are almost like 150 plus countries only out of 230. Why? Because we know by the March last week, 98% of the countries had registered their index case. It is spread to the entire world by March last week. So that is the reason we have scraped the data only for January, February, and March. So we can just go ahead and see, we'll execute the query and we'll see which is the date most of the countries have registered the case. So in this query, we are calling the nodes of the predecessor country. We are calling the nodes of the successor country with the relation. And we see that here, every country has a property. It has a date property here. You can see different dates. On Australia, the index case was registered on 25th January. So we are calling this date and we are counting the number of countries and doing an order by the descending order. Now we can see the output here. On March 13, 2020, 20 countries are registered on a single day itself. Now the second highest we see on the 26th February, only 5 countries. But March 13th is a date where 20 countries have registered their index case. Now let's see, go into much more detail, what are those 20 countries and how the virus had spread. So now I'm executing another query here where we have calling, we are matching the predecessor country node to the successor country node, and that belongs to a continent. And since we know the answer, it is March 13th, we are passing this filter to get the nodes, only those countries that have registered their index case. I'm just executing this query. Now we can see the output here. Now on March 13, 2020, there are 20 countries registered their first index case, which belongs to 4 different continents here. This is the output we can see very clearly. 20 different countries from 10, the predecessor countries are 10 here. From 10 different countries, it has spread across 4 different continents. Almost like 2 countries has contributed to almost like 50% of the cases on a single day. So these kind of visualizations, when we don't have this kind of data set directly available on the internet, we can use these web scraping tools to get that kind of information and prepare these visualizations. Now, since we've seen this and we got the answer, that's March 13th, where 20 countries were registered. That's the highest registered index cases. Now let's do something new, which is not available on the internet. Like now, let's talk about the homonymous cities. So this is all. I'll just stop this. Okay. Now we can see list of homonymous cities. Okay, now you can see here, there is no such kind of web page on the internet itself. Wikipedia has not created this kind of web page. So there is no such page like homonymous cities. Homonymous cities is nothing but a city name that is a city with the same name that is present in different states. Okay, so this kind of information is not available. For the first time, using Neo4j, we'll create this visualization today. And just to see, we'll see the process here. Okay, now we follow the same process like homonymous cities. Let's start with the one question here. Which is the most common city name across the globe? If any of you don't know the answer, we'll find it in next few minutes. So we follow the same process step by step here. First, we gather data from multiple web pages. Why multiple web pages? Because each country has its own unique web page. It's like a list of states in a specific country, list of prefectures in a specific country. Like, so we gather all that information, we create our queries, we create our graph database. So we just query on our graph database and we find the answer. So just to understand the data patterns here, so it is always good to go in a structured way. So if you go in a structured way, we can build the relationships very easily. Now you can go and check directly a list of cities in a specific country. Instead, we go in a stepwise manner, list of countries in continents, then list of counties and states in the countries, then list of towns or cities in that specific state or prefectures. So let's go to our Neo4j here. And so I'll just load the data that we have here for the homonymous cities, which was scraped from the internet, from all the countries, from all the states, from all the cities and all. So we'll see now. So this is the output. So just executing. So because we have so many homonymous cities, we have so many cities like that. But the thing here is we need to identify which is the mostly used name across the globe here. So you can see it's more clustered here because we have almost 500 plus cities. At least they are used more than once. They are more than the city name is present more than once in a different state or in a different country. So this is in a more clustered way. So we have the data set ready. But anyhow, we have our database ready here, graph database with all the information. Now let's execute query on this database to find answer to our question, which is that homonymous city, which is that city mostly used across the globe. So we'll go back to our browser. Okay, and so I'm just executing one query here. So I'm just matching the city which belongs to, which is the city of a particular state, and we are just counting the number of times it is occurring, and we are just doing a descending order and just limit one, which means that we are identifying the mostly used, the most times it is present. This is just one way of writing query. So I'm just executing this one. So let's see the answer, which is that city mostly used across the globe. So we see that San Antonio. So this city with the name San Antonio is there in 34 different states. So we'll see in much more detail. We'll just quickly switch to Bloom, and we'll see in much more detail where this San Antonio is present. Is it in multiple countries like that? So Neo4j Bloom is an amazing tool where we can visualize this kind of information. So I'm just creating a new scene here. So San Antonio. So I'm just entering the city name here. So I would like to know the San Antonio with all these nodes to which state it belongs to. So which state it belongs to, and I would like to know the nations also. So I'm just entering the nation here. So when we execute this, we can see the output here. Yes, you can see it clearly. See, San Antonio is here. Now San Antonio, this is the same name. So there are many states with the same name, having at least once the San Antonio as a one of the city names. So we have Costa Rica, Puerto Rico, Colombia, and all. So if we see here in a much more detail, so there is one country like it's part of United States as well. Okay, so we have Mexico here. We just pull the Mexico to the left hand side, and we can see Mexico itself has almost 9 times. So Mexico has 9 states where San Antonio name is used here. So if we just open this and check in detail, so we know that San Antonio city is present in 34 states, sorry. So 34 states belong to 17 different nations. So this kind of visualizations, when we have the data available in the graph database, so we can easily visualize much more in detail. Or now, so let's see, so is this the only detail we get? So basically in Neo4j Bloom, we used to find the shortest paths. Like let's say in our case, we'll find the relationship between 2 countries. Now let's create the scene here. Now I'm just taking 2 countries to identify the relationship between them. So let's take India first, and then I'm taking United States. Okay, let's find the shortest path, which means that how the both countries are related. For example, here when we check for the shortest path, yes, Salem, which is a city of Tamil Nadu state in India. It's a city of North Carolina, which is a state of United States. Now, is this the only relationship? Is this the only states that has this information? Because Neo4j always gives the best shortest path in the randomly. Maybe when next time when we execute, it might be different. So I just want to go into more detail to understand the relationship of Salem's. Okay, so now let's clear the scene here. Now we'll just go, we'll use Salem. So Salem is a city. We need to know what all the state names which has at least one city with the name Salem. So the state, and I would like to know the nation names also. So when we execute this, yeah, you can see here. So many, there are multiple countries. So let's pull the United States here. Sweden also has one of the state where the name Salem. South Africa, Indonesia, Germany, and India. We already seen in the example earlier. So now when we see this, see the arrangement here. Now there are so many states in the United States where at least one, they have one city with the name Salem. There are almost 18 states in the United States. Like there should be some reason, right? Like when we look at the history, there are some amazing books like the Indian tribes of Northern America. So where it talks about in much more detail. Okay, and there could be many reasons like related to tradition, culture, any trading. So all these things can be discussed in much more detail. So if we see here South Africa, where the Salem is part of, it has a city name in Eastern Cape, it has some biblical origins when we look at the history. So like this, we can go into much more detail, especially useful for the historians, even for the geologists and archaeologists when they are working on a specific relationship between 2 countries to understand the culture and tradition in more detail. So this kind of amazing information, this kind of relationships, we can build on Neo4j Bloom and can be used across the. So yeah, so now we seen the answer to our question, like the San Antonio is the city name, which is mostly used across the globe. Just coming to the conclusion. So these are all talk about like scraping data from multiple sources with beautiful soup for creating better visualizations and all. So like this, when we don't have any data set readily available and you want to create a visualization and you have an idea to create something new, definitely internet is our database. And by finding a few data patterns, we can create some amazing visualizations using technologies like Neo4j. And now like we gathered multiple sources from Wikipedia, research journals, and these kind of visualizations, they are definitely helpful in academics and historians. As we see now, it is used across the domains because to get much more deeper insights, and especially for exploring any kind of correlated data, it is really interesting in any context. In any context, when we have much more correlated data, we can find some deeper insights by using these amazing tools like Neo4j. And yeah, thank you all, and thank you Neo4j for giving me this opportunity. So I'm open for any questions.
need to unmute myself.
Cool. Yeah. Very cool. Very cool. I think that's such a lovely. That's a simple but an elegant example of what you can do, and I think it's one of those things where it encourages that curiosity, doesn't it? Like how many places around the world have got a city named Salem? Like that is I can almost see, like, can we drag some data sources in as well where you get like name definitions, and is it the case of that they've all got the same name because there's the same root in history, or is it coincidence? But yeah. Hello, good afternoon.
Hi, Lipska. Hi, Alexander. Good morning.
Hi, Rajesh. Good afternoon to you. Thank you very much for joining us today, Rajesh. So you are Senior Application Developer leading the Graph Analytics stack at Fujitsu Consulting in India. So thank you for joining, and thank you for the cool presentation from last year, which we now can use as a talking point. But maybe you want to share a few sentences about yourself before we dive in.
Yeah, sure. Thank you. Firstly, thank you for the opportunity to connect with you all in this Notes 2021, and thank you for this opportunity again and again. And so actually, last year on the Notes 2020, so just before, we don't have much experience into the graph analytics and all. So we are from the analytics team background, but graph analytics was totally new coming before Notes 2020. So in just 6 months, we are into the graph analytics. The tool that we can learn within no time, we can understand the kind of trainings that were given, that were coaches that were provided on Graph Academy. They're very much useful to us. So that's when we picked up very soon, and we are able to come up with some unique use cases. As you've seen, we try to understand like what kind of visualizations are not available on the internet. So we searched for it. We tried to come up. It's like we are trying to understand the ability of the tool, what it can do for the use cases that were not available yet. So that's when we are able to do that presentation last year. Thank you for that.
Cool. And we actually had a couple of questions in chat on about your presentation. So maybe we can go into that. So let me slide this one in. So Anshu said, what a nice use case. Yeah, and I agree. But can we get the comparison of why this can't be done by relation database on the basis of performance data joins time consuming and so forth? So maybe you can, you said,
Yeah. So see, now if you see the presentation, I had loaded the entire data using an Excel sheet. So that's when I loaded the data, right? So to get the data into that Excel sheet, we have used some scraping tools like Beautiful Soup and all. Now, the kind of visualization that was done on Neo4j Bloom, just to understand from everybody's perspective, is it possible to do it on an Excel sheet? Is it possible to try to understand the relationship on any kind of BI tool? So just trying to understand. So that's what I have done. That's a very good question, because from that question only we had come to this presentation last year. So we started with that question. Why can't I do this using some other storytelling tool? Yeah, of course, a storytelling tool, I can show all the nodes. I cannot show the relationships in a single glance. Now, when I showed you, as Lujika said just now, like how many Salems are there? I just drill down and filter on a particular country. I can show you that there are some 18 city names with the same name as Salem. But when I show you on Neo4j Bloom, the perspective is totally different. I mean, your question has not stopped there. You are interested to know why these many relationships. What is the background of it? Like, is it really some trade or some tradition? How come somewhere South Pole and North Pole has the same names, or somewhere another continent has the same names? So it's a detailed study. So that's when that's why I always highlight in the presentation the tool, like an amazing tools like Neo4j. It's not only about the storytelling; it's always about finding the relationships as well. So that makes it more interesting. Yeah.
No,
I
absolutely.
Yes.
Almost, I think your example as well with the cities and the countries, it's sort of like, so one of my things I love etymology. So the history behind words, how does a word come about? What's the backstory? And by extension, I would love to see, like, can you imagine how you extend this out in the cities as well? Because I'm absolutely certain, like, obviously, let's pick York and New York. Let's pick a really silly example. Obviously, New York got its name from York in the UK. So that historically, that's what's happened. It used to be called New Amsterdam. Surprise, surprise, that was because of Amsterdam in the Netherlands. But the really fun thing is that you're going to get a situation where you're going to have places where they've got the same name. And that's just pure coincidence. You can have a group of them because they've come from this history. You can have a group of the other ones that come from another history. And the really exciting thing, I guess, is can you dig down further enough? You know, is there an ontology where you can keep digging where maybe eventually they join back up? Who knows? But yeah, and like you say, you're not going to get that on an Excel sheet, are you? But when you start pulling those things together, it excites your curiosity to just keep digging.
True, very true. And we keep hearing about the sister cities. Now they are coming up, helping each other, and also there's much more in this context. Actually.
Absolutely.
Yeah, I think visualization is a great advantage of the whole graph concept, because you can represent something in an Excel sheet, and you probably can have the same information there. But if you compare an Excel sheet or any table structured form with a graph side by side, any whatever the concept is in the graph visualization, you will always be faster in recognizing what's going on here, what's meant here, where are the connections, where's a weak point, what's the structure like. Whereas in a table structure, you will always have to read every single line, and then you have to look into it. It's very complicated.
And that's right point, Alice. Like you said about the performance. So just one small point to add here. Now let's take in the BI market, in the business intelligence market, or any kind of visualization tools that we have. Any BI tool, when they highlight the product, I mean, just in a normal perspective, I'm saying, when we highlight the product, the features of the product, it falls into either of two categories. Either they talk about the speed or they talk about the visualization. Now, let's say memory analysis or something like our performance is good, or let's say kind of different. They are coming with a unique concept of analysis. It comes under the speed category. Or let's say they come up with like we can do some nice storytelling. We can do a better visualization. We can make nice kind of glances on a single shot. All these fall into the visualization category. So there are only two categories. Like one is speed, which is nothing but performance, and the other one is visualization. What we have seen is in Neo4j, it falls into both the categories. We see in the visualization in a single glance, and the kind of we can see to make these kind of visualizations, the kind of joins are required, performance issues, everything is covered in that. So that's when we choose the right tools for right visualizations.
So just as a quick question, what else have you applied this on? Are there any other fun data sets that you've gone off and gone, right, I'm pulling that straight into a graph?
So after Notes 2020, so whatever we have done, so we are just trying for something unique, like I have to say in a simple words, like we want to do something on the untapped data till now, like the data which is ignored, or maybe the public felt which is not important at all. So that's when the real value comes from the untapped data. So we started something on the sustainable development goals data. Now we see every organization is contributing towards sustainable development goals. So it's no more a choice for an organization. Everybody is keenly interested to contribute more and more towards these goals. Now let's see, everybody is like as an individual, I am interested in one particular SDG. I focus more on clean water and sanitation, for example. So I'm completely focused on that. I am involved only in those activities. But though I know the other SDGs 16 names, but I was never totally involved in it. So what we try to understand is these sustainable development goals that we have, the 17 sustainable development goals, they cannot be treated individually. They are interlinked with each other. So that's when we try to understand. And it's not that easy to make a statement that they're interlinked. We need to have some data proof. And at the same time, we need to visualize something as a proof that they are interlinked with each other. That's when we started picking up each sustainable development goal, going in depth of it. I mean, collecting more data related to that SDG, and trying to link with the other data set from the other SDG. So this has become a challenge, and the more than coding or the other technology part, doing a proper study on the data, the kind of SDG sustainable development data provides, that has become a more challenge. Because when you see these individual sustainable development goals, they have 8 to 12 subcategories. And as an employee in every organization, like we just see what is the SDG name, and we just try to contribute only to that particular water sanitation or good health. We don't do a deep study because that's not part of something. So we just go only with the SDG names. So what we are trying to understand is how they are interlinked with each other. So the 17 SDGs are interlinked with each other, and we felt basically that Neo4j is the best tool to visualize these kind of relationships. So that's what currently is going on. Yeah.
Oh, I love that, and it's just sort of spinning in my head as well, where I think if you start taking it further, and if you can start pulling data sources in, because I think you talked about water quality, and water quality is a great example, and some of the things that will be looked at water quality as well as pollutants and whatever else would be acidity. Acidity is a great example of something that you look at for water quality. And the thing with acidity of water, that's going to be indirectly related to pollution in the air. So the more carbon you're emitting into the air and the other sort of carbon factor emittents in the air, eventually they're going to end up in the water. So even though those are two distinct things that you would look at for measuring and improving, if you're looking at it in isolation, you're going to go, well, why is my water so acidic? Is it runoff from the environment, things like that? And you're thinking, well, actually, no, there is an indirect connection from what you're chucking into the sky and eventually linking in. Oh, I love that. And that's amazing. And can you imagine if you can start getting a rough estimate of, percentage X of this city putting Y amount of carbon and carbon factor emittents into the skies, having an impact on Y city over here's river acidity levels. Oh, I love that. That is amazing.
Thank you. So like that. So as you said, one relationship with the clean water and sanitation, like clean water is directly related to good health as well, or SDG 3, good health and well-being. They both are interlinked with each other. You cannot separate them and look as a distinct thing. So what happens usually, when we go with the data on Excel sheets or something, we look at them as an individual sustainable development goal, and we try to contribute only on that part. But when we interlink and see, we just come up with some of the root cases which were never discussed also. That's make it more relevant, and the organization also can focus on those particular reasons. It will be a good decision making system if implemented in
Absolutely.
Yeah, and it's always important to get the, like you said, the various sources in, and then you build it up. And then in particular in this case, you're talking about water or general goods where you don't have mostly a very technical audience you talk to about the topics. When you have something that is very visual and very, very easy to understand, where you don't have to explain lots of difficult it's a difficult and a complicated topic, but if you are able to present it in an understandable sort of easy way, then everybody can follow along and still say, hey, yeah, I see, I'm the expert on waterworks maybe, so I have no technical, no IT background really, but I say, okay, I look at this and I say, okay, yeah, here is an issue, we have to talk about this. That is super helpful.
Absolutely. No, absolutely. Oh, it's so cool. So cool.
Yeah.
So I guess what else? So obviously you've started off doing a lot of stuff with Neo4j. So you've started how I would argue 95% of anybody, they start off with an Excel spreadsheet or a CSV, and they pull that data into the database. So you've done that. You've been working with Bloom. Have you been adding anything else to this journey? Any other technologies being brought in? Any other sort of things?
Okay, so nothing new. Like everybody knows, like Neo4j GraphQL. I think this is like an add-on to us now. Neo4j GraphQL library. It's like I said, ideas are turning into reality now. So very quickly to visualize. It's not taking much time. So that's what I highlighted. So there's no challenges at the code level. So we just try to understand on the basics, like like the guys who don't have any knowledge on the GraphQL side. So as per my understanding, within a couple of hours, they can start working on Neo4j GraphQL when they go to the entire course. So it is that quick and easy to understand. So the challenge here is to understand only the data patterns, how to bring the data and how to visualize in a proper relationships. That's been a challenge since the beginning. So I would like to say Neo4j GraphQL has been an added advantage in this journey.
Have you been using it? What kind of setup?
Right. So as of now, so as the example I have given you for SDG6 and SDG3, so we just created a schema on that. So the type of events that has been connected to an organization, how these single event will contribute to multiple SDGs. So that's when we are focusing as of now, and definitely it's an add-on to us.
Cool. So it's like basically a mechanism to quickly get that data in.
Exactly.
Right. Oh, I love that. Oh, fantastic. So I guess what's next? Where does this journey continue?
I think it took almost like 4 to 6 months to understand a couple of SDGs. When we go into the data into much more detail, it leads into more and more details. Actually, as I told you, each SDG has 8 to 12 categories. So we need to understand how these 12 categories are related first. Then we need to relate these 12 categories to the other 8 to 12 categories from other SDGs. So to understand at the data level, it just takes time. But as of now, we are able to come up with our first point. We related two SDGs in a meaningful way. So where people can relate it very easily, how water and the good health and well-being are very much related. It cannot be looked as a standalone things. So yeah, so we continue with the study on the other SDGs as well.
Oh, brilliant!
Cool, very cool. You mentioned in the the little email exchange we had before that you are also looking into emerging technologies like 5G. Is there anything you can share?
Right. See, we know that in the EU27, almost 24 countries had already 5G implemented. And in India, the latest news, yesterday also in one of the famous city, the 5G trails has been going on. So no sooner or later, when we talk about 5G, we talk only about the connected world, right? Mm-hmm. We have multiple use cases already in the market. Let's talk about manufacturing, either manufacturing or automotive, public sector, or let's say public transport or any health kind of domain. So there's much more scope. So even if you see, the data is going to flow like anything in the near future. Now everything is interlinked data. We have to understand that. So nothing can be seen as a standalone in the near future. Everything is interlinked. So let's say the kind of autonomous vehicles, the more and more we are talking, because of 5G is coming into the market. Let's say like a vehicle to vehicle communication, or vehicle to infrastructure, or vehicle to even vehicle to pedestrian communication. So everything is interlinked here. Nothing can be seen as standalone. So in this kind of interlinked data, in this kind of understanding how to understand these relationships, so we see Neo4j GraphQL APIs. They have a very, very good potential to implement in multiple industries. As I told you, manufacturing, automotive, let's say even in agriculture, everything is going to be on IoT. You cannot, if you speak a bit more technical on the IoT front, a single sensor cannot tell all the story. It's always about the multiple sensors. Now the question here is, how do we come up with this sensor fusion technologies? How do we integrate them? When you integrate, how do you find the relationship between data? So it's going to be a challenge. It's going to be an additional research in each and every field. So this is where we see the potential of Neo4j graph databases and GraphQL APIs. So that's where we are focusing.
Cool. Yeah, that's graphs are everywhere will mean a completely different thing then.
Indeed.
Cool. Well, thank you very much, Rajesh. Thank you for joining us this today before Nodes 2021. Thank you for taking the time and sharing again your insights with us and the people watching us now. So, any last words? Anything you're looking forward to Nodes in particular later today?
Right. So we have a couple of sessions from our Fujitsu colleagues. So I'm going to be more interesting. So they are on the best practice track. Okay, and I'm not going to miss anything on the GraphQL API session. So there's so many interesting sessions, and you can see the past, present, future of Neo4j and GraphQL. So this is going to be very interesting, and William's session on best practicing of using Cypher with Neo4j GraphQL. So definitely very interesting sessions ahead.
Super. Cool.
Fantastic. Yeah. Thank you so much. And I'm looking forward to keeping an eye on what you're doing with the environmental factors and the tracking side and when data's flowing, because I think that is super cool.
Thank you. Thank you, Ulrika. Thank you, Listen. Thank you so much for it.
Thank you for joining us today. Bye-bye. Take care. Have a good day.
Bye-bye.
Thank you. Bye-bye.
So cool.
So cool. Yeah, indeed. That is, yeah, it's amazing. I mean, visualization is helping so much in adoption and in understanding what complicated scenarios become a little bit more easy if you see it visualized differently, and the graph is a very visual tool. Yeah,
absolutely. So one thing I just want to quickly say, so you've had a few questions coming up in the chat. So Matt W has got a few questions with regards to why would you never use a relational database again, that kind of thing. So the only thing I'll say is we will hopefully have a bit of a gap in the schedule later on. So watch this space. If you've got any questions around this, let's have, I think we may have like 5-10 minutes, so we can probably explore some of those questions. So hold on to your hats. If you've got any more related questions, you've seen what matters, pop them in and let's see if we can have a bit of a conversation, because we've got Michael joining us at the end as well. So maybe we can steal in a bit of time and do a bit of, we can do an impromptu panel session.
Oh, yeah, that sounds good. Yeah, exactly. Cool. Yeah, pop in your questions. We will remember them, and we will if you like, yeah, some time.
Absolutely.
All right, let's look at the agenda. So we had just talked to Rajesh, and maybe now it's time for another quick recap. What is Nodes and what is to come later in the day? So Nodes is our developer-focused event. So really is from Neo4j / community developers for developers. So that's really the target. We will have very in-depth session in 5 different tracks. 50 tracks in 50 talks in total, so it's a huge number. But don't worry if you nobody can watch them all at the same time, obviously. But you can make your agenda. You can look what you are interested in watching live. But everything else will be available as a recording afterwards. So even if you cannot make everything, you will get the link to the recordings. So register. And the cool thing is, 98% of the sessions today will be live. So we will have almost no recorded sessions. Everybody will participate live. So it's really cool. I think it's a different kind of feel if you are doing it live in front of an audience that you know is there and watching you. So that's going to be good. And yeah, interactive, engaging panel conversations and Q&As will be also interlinked between the talks. So then the whole audience comes together in a big group, and you can talk and chat with everybody else and see who's around and ask questions. So I think that's going to be very exciting. What else should you know? So yeah, really don't forget the closing keynote. So yes, there's an opening keynote done by Emil. So everybody is looking forward to that. I'm pretty sure that's going to be the big bang opener. But they're also going to be a big bang closer. I don't know, with Jim Weber. So it's going to be very funny. I think so. Jim is usually funny. So I'm looking forward to that. And
it involves members of our community as well, which is
exactly
cool.
Yes, yeah. So it's also going to be interactive, and if interactive is your thing, we've got audio and text channels set up on Discord. So if you're watching on Twitch, you can use !Discord to get the link. Otherwise, type in dev.neo4j.com/chat, and you'll be directed there. Once you join our Discord server, type in !Nodes, and then you will be granted access to our secret Nodes 2021 channels and voice chats. So then you can directly talk to everybody else that is watching Nodes 2021.
Absolutely. So let's look at another track.
Yeah, exactly. Before we do, another shout out to our community partners here across the globe. These communities help us make Notes 2021 a success. So really, thank you to all of those great people supporting and helping out with the conference.
Absolutely. Thank you. Thank you.
The next track is the visualization track.
Yes, so unsurprisingly,
yeah,
it is mainly about visualization. So this will be about how people are using visualization tools or tool that's sort of in use, and the use cases. So very sort of visual analytics of the data. So let's just pull out a few of these that are good fun. So the exploring Neo4j motif, I think that's looking around how can you combine things such as Neo4j and Jupyter Notebooks. So how can you build that bridge between sort of your data scientist and your business user, and have some kind of a bridge between those two. Neo4j Bloom. So for those of you, well, if you watched the previous talk, you'd have seen Neo4j Bloom in action. So again, a quick talk about how you use Neo4j for answering questions and things like that. And for those of you who are interested, I did do last week a training course on Neo4j Bloom. So if you were looking at what Rajesh was doing earlier and you're like, oh, that sounds cool, you can on demand watch that. So it's a 2-hour session and we literally go from 0 to 60. So if you're interested, we'll try and get a link in the chat as well if you're interested. So next one, revealing the life of a Twitter troll. So this is all about, I know. How can you not want to go off and look at that?
Yeah.
So basically just looking at how people are exploiting different parts of Twitter. So exploiting hashtags, creating fake personas and that kind of thing, and just visualizing what's going on under the bonnet there. And another one, again, quite a popular topic, this idea, this fits in a lot from what Polly was talking about earlier about transparency. So this is, and we've got quite a few talks that just keep running on that theme of transparency about how do you, how do you make it more transparent what's going on? So this is, again, so this one here is all about the transparency of looking at how an organization is set up and those connections with auditors and that kind of thing. Again, fraud detection, it's another transparency one, just exposing what's going on and being able to see, how do you combine these various elements together, and how do you combine machine learning, how do you combine visualization, how do you combine elements of the graph to pull these things together. So, great fun. Microservices. So this, I think the abstract for this one is, what if your architecture diagram was also your executable artifact and your process documentation? How do you do 3 things with one thing? Watch that talk and find out more. And modeling physical systems. So this is all about looking at natural resources. So you think about sort of ecology and the environment. So again, probably a bit of a tie from our previous speaker. So you look at the natural environment and effectively, how do you start modeling that? So how do you start modeling like lakes and reservoirs and landscapes and pulling those things together? AVR graph, I think this is one that Priya was mentioning earlier. So graph, VR.
It's exciting. I'm looking forward to that one. I think that's ever since I think I saw an early demo of somebody exploring a graph in VR. I was like, oh wow, this is so cool. This needs to be happening more. And now I think the technology is catching up a little bit more. And I think this is super cool. Yeah.
Absolutely. And creating your first graph visualization. So this is really interesting. So I think there's a big trend at the moment for low code, no code. And yeah, the session's about 10 minutes. How do you set something up and ready to visualize? So that'd be really cool. And
it's going to be surprising, I think, for people. And we said is a technical and developer focused conference, and yes, it is. But some of these sessions are easy to understand for everybody, and this is one of those where you, even if you have no idea what's going on, with graphs, you can follow this, and it's super easy how quickly you can generate some first visualizations without typing any code. So it's really good.
Absolutely. And the last talk of the track. So this is a really this is a big area, has been certainly over the past sort of 5 years. Know your customer, all about knowing, where they're connected, who they're connected to. Are they using different personas? Is there weird groups of connections that you need to be aware of? So again, and this sort of focused in the gaming sector. So again, another sort of going to be very interesting. Again, same theme, transparency. How do we create transparency about what's going on? Yeah, so that's the visualization track for those of you who are interested. I'm going to quickly post the link for the side-by-side. I know Kim asked about it earlier, so I'm going to pop it in the chat. So again, you can quickly remind yourself of the different tracks and talks going on. I've just popped that in the chat to look at the agenda. And I guess it's now time for our next video.
Exactly. So we have, let me scroll back a little bit here to the agenda. Next up, we have Luan, who is VP of Engineering at GraphAware, and we will revisit her 2020 talk on about Maltaware discovering what to drink with Neo4j. We will showcase that now. Again, use chat for questions and discussion points. And afterwards, we have Luan live on stage again. We will discuss with her, about the talk, about what she's doing now, and what she's looking forward to. With that, we'll see you on the other side. Enjoy.
What better way to start this amazing event than with the perfect single malt? Good evening or good morning, everyone. I'm Luan, and I run engineering at GraphAware. We do all things graphs and Neo4j, and we're the creators of Hume, a graph-powered insight engine. You're going to hear 5 of us speaking today on topics ranging from graph visualizations to NLP and security. Right now, though, I'm going to be talking about recommendations with Neo4j. Recommendation engines have always been a popular use case for Neo4j, and I'm going to show you why that is and the different ways to produce good recommendations with very little effort. We will start with a data set of whiskeys and go through a progression of recommendations such as content-based, collaborative, and some special ones to mix things up. Why even implement recommender systems? So recommendations are everywhere, like graphs. They show up when you shop, when you plan a holiday, social networks. Traditionally, recommender systems were a type of information filtering system used mostly in commercial applications to predict a rating or a preference that a user would give to an item. Now with the knowledge systems and inference engines, they blend together a bit to extend to fields such as finance, to find fraudulent transactions, to law enforcement, to find people of interest, and so on. The main challenges for a real-time recommendation system are 1, to discover the items to recommend, 2, to pick the most relevant ones to present to the user, and 3, to find those relevant recommendations as quickly as possible. So what do these systems do? Because they try to predict how much a user will like or prefer a given item or target, they assist users in decision-making. They also take into account business strategies, since ultimately the goal of recommendations is to increase business or retention rates and such. They don't just treat each user as interchangeable beings, but they try to personalize recommendations or take into account the context. And they do this by correlating different data angles to come up with and what they believe fits best for each unique user. And all this has to be done in a performant and a time-sensitive fashion, since recommendations calculated a day ago may already not be relevant at the current time. And they need to be explainable so that we can deduce how successful they are and tune them if they're not. Now, decades have passed since software systems that are now called recommender systems were first developed, but the field continues to grow and improve to provide more and more accurate recommendations. They aren't always easy, and some of them continue to amaze every single day with their very diverse recommendations. So no matter which way I try to reverse engineers these treatment for aquariums, which I have never dealt with nor shown any interest in at all, seems really very strange. And the wire baskets as well, in fact. But recommendations and graphs were made for each other, and today we will see why this is. Now, top-selling items is no longer good enough. The you may also like is a modern way to offer tailor-made suggestions and provide very real-time targeted recommendations to potential consumers. The underlying technology has to support this. There's a buying history to capture and also analyze together with current choices or indicators. And then we match this all up to provide the best recommendations. And this has to be done fairly quickly before consumers, especially in today's digital and time-pressed world, begin to move on to another website. So graph databases give equal importance to storing both the data, which is customers, products, categories, etc., and the relationships between them. Who bought what, who likes what, which purchase happened first. It's a semantic-rich model, providing context in the form of named and directed relationships between nodes or entities. So we can represent users and the items that they've bought or indicated some interest in, the features of the users, their preferences, their tastes, demographics, and so much more in a graph, and traverse this graph really fast to derive some value from those relationships without incurring the high join cost when you model this data in rows and columns. Why do you receive or not receive the recommendations that you expect? Because we recommend items based on how they're connected, what features they have in common, what characteristics they share, tracing the reasons for the recommendation and hypothesizing about the various parts that cause the item to be recommended is significantly easier in a graph. Of course, there are some values that could be calculated, such as the similarity, but even in those cases, based on the input to the similarity algorithms or calculations, we have a fair idea into why it is the way it is. And in fact, this is exactly how I tuned some of the queries or the calculations for the graph that we're going to see today. Apart from this, graph models are self-explanatory. They are easy to understand by non-technical users, and they're very easily visualized. So overall, graph-based recommendations are easier to explain than black box statistical approaches. Neo4j is a schema-free database without the rigid structure of SQL databases, which make schema changes hard and mostly scary in production. With Neo4j, it's easy to not only add properties or types of nodes or relationships, but also to refactor the schema fairly easily. Plus, it's also possible to have the old and the refactored models coexist till all dependent applications can migrate. Neo4j is often used as a storage layer that connects data from multiple silos, and having quick access to everything you know about a user or a product allows you to make more relevant recommendations. Recommender systems typically need to analyze a large amount of data to produce meaningful results. So Neo4j's native graph engine uses index-free adjacency to eliminate the need for these complex joins and enable real-time traversals. So for today, here are the concepts that we're going to visit. We're going to talk about personalized recommendations, because recommendations that aren't personalized aren't very useful at all. So different recommendations for different users based on taste. Now, since we speak of personalized recommendations, the system needs to know as much as possible about users and items. And this typically takes the form of a set of features or characteristics of an item or the preferences and behaviors of the user. And these are commonly known as user or item profiles or user or item models. Now, how these models get built range from very simple, as we will see today, to those built out of sophisticated learning algorithms. And the features can be collected implicitly or explicitly. So for example, we derive some characteristics of users by analyzing the whiskeys they rated highly. This is implicit collection. We also asked a subset of users to indicate their favorite flavors, and this is explicit. Now, with collaborative approaches, the central idea is to use information about the past behavior or the opinions of an existing user community to predict which items the current user will be interested in. This method suffers from the assumptions that if users had similar tastes in the past, then they will have similar tastes in the future, and that their preferences remain stable over time. But we'll see some ways to get around that today. And finally, context. Context is very important. And this ranges from things like who you're with, who you are maybe purchasing things for, location, time, seasons, all these sorts of things. Right, so here's the graph model that we are going to use today. At the center, you see the most important entity or node, which is the whiskey. And we have a couple of descriptive nodes surrounding it. So we've extracted the flavors. So the taste profile, you may say, of the whiskey. For quite a few of them, we know which region they come from. For a smaller set, we know what cask they were aged in, because cask is quite important. We know the bottler, not so important. And we, at least with the data we have, and we have a set of people, users, that have actually reviewed these whiskeys, and they've provided a rating on the scale of 1 to 5. So that rating, in fact, is stored as a property on the reviewed relationship. And the reviewers will represent all our users today. So it's a small data set, but nice enough to explore and test out our hypothesis. And we're going to start from the beginning. So we're going to onboard some users. We are going to start recommending some whiskeys, and we're going to improve as we go along. So the cold start problem. Now, this is quite typical of collaborative systems where users, they don't have enough history, or there are just too few users to be able to use the opinion of the broader community. And in fact, that's the very case with our graph today. Now, this can also apply to new users which haven't been reviewed yet. So in collaborative system, if new items haven't been reviewed yet, they would just fail to be recommended because they would not be picked up. Now, this can be quite a serious problem because it can result in the loss of new users who stop using the system due to inaccurate recommendations. And in fact, their own lack of history is like a perverse contributor to this whole phenomenon. So instead of providing subpar recommendations based on insufficient ratings in the system, let's just have the system not use a collaborative approach till the distribution of users and their ratings crosses a certain threshold. So different domains attempt to tackle this in different ways. And in our case, we are going to start off by recommending whiskeys that the general population seems to like. On our whiskeys today, we have a couple of external indicators in the form of a category. So these are pre-categorized. And they're categories like smoky whiskeys or the floral ones or the fruity ones. So what we're going to do is present generally liked whiskeys across these categories, and this should be a good enough variety, and we hope that there's something in there for everyone. So here's our initial recommender query, right? We'll walk through it. It's pretty simple. We find all whiskeys that have at least 2 reviews. Now remember, our user base is fairly small, and we are onboarding new users into this graph. So we don't want to do collaborative recommendations because they are likely to be fairly inaccurate. So all whiskeys that have at least 2 reviews, okay? We are going to check what rating they have. So the average rating, we want to make sure that they have at least a rating of 3. We don't want to rate whiskeys that nobody really likes. And we're also going to make sure that the general population of reviewers sort of agree on the rating. So there isn't too much deviation in those ratings. We will pick 3 from every category. So we have like a nice mix, and that's what we present. So here you see these are the whiskeys that we're going to just recommend to brand new users who try to use our system. Now the little colored badges on those whiskeys represent actually the category. So for example, the blue ones are the smoky whiskeys, typically with a lot of sea flavor, so a lot of brine in them. The pink ones are fresh fruit with a lot of vanilla. The black are the richly peated ones. Yellow, heavy on the malt and the honey, etc. Right? So we took this initial set of whiskeys and we ran it across our test users, and we actually found that every single user found at least 2 to 3 whiskeys that he or she had tried before, mostly liked, and one or two dislikes, right? So we see over here there are 3 users, and all of them have found or whiskey that they've tried before or that they might want to try. So not a bad way to start recommending whiskeys, right? We haven't put off users from staying on our site already. So now let's move ahead to content-based recommendations. So these lean more towards the information filtering technique, and it's based on the profile of user preferences matching with item characteristics. So now in some cases, the item features are manually created. So for example, every whiskey can arrive with a tasting profile from the distillery, indicating characteristics such as smokiness or sweetness and whether it's chill filtered or not. And having this provided uniformly is usually feasible only in smaller systems that deal with mostly like a single source of curated data. So then we have the features that can be extracted, typically from text, such as descriptions or reviews, or from metadata, or from catalogs, for example, that the distiller produces, the region, the type of cask. So for users, their preferences can either be indicated explicitly or inferred from their behavior. We are creating a content-based user profile or model based on a weighted vector of item features. And today we're going to go very, very simple, just to show you that you can start building recommendations quite easily from even basic graphs and then add on the complexity as you go. So the advantages of this method is that it doesn't actually rely on the existence of a large user set. And because the characteristics of the items are used and not their ratings by previous users, new items can be recommended almost immediately. And this is why content-based recommendations are potential other solutions to the cold start problems. However, this method does have its disadvantages. It definitely requires some domain knowledge to produce a good model. And it is constrained to making recommendations based on the existing interests of users. So it tends to not actually venture into new territories. So generally, whiskey drinkers tend to favor certain flavors. So in our graph, we've extracted the flavors of whiskeys from the content of the description and the reviews. And we can now easily see how the flavors related to these whiskeys also serve to paint a picture of our users without them having to explicitly state their preferences. So this particular subgraph shows our user with whiskeys that he has rated highly. So we see Franta with the brine and the smoke, typical characteristics of the Islay whiskeys, and he favors the toffee notes as well. And a different profile, this time mine, leaning heavily towards the peated whiskeys. You see the smoke in the center of it all, brine, some fruit. And we begin to see that some whiskeys are close to each other in terms of flavor profiles. So as I said, the colored badges indicate some of the data that we already have around their categorizations. But even without the blue ones indicating the seaside smoky whiskeys or the black ones indicating the richly peated ones, we can see quite clearly that their flavors alone tend to bring them together. So we are going to use the flavor profile of whiskeys to calculate how similar they are to one another. Then we will use the ratings of our user to find the whiskeys that he or she liked, traverse through to similar whiskeys and recommend those. To calculate the similarity score, we will use an algorithm from Neo4j's Graph Data Science library, so the node similarity. This algorithm compares a set of nodes based on the nodes they are connected to. And this fits quite nicely with our flavors. So two whiskeys will be considered similar if they share neighboring flavors. Now this particular one computes similarity based on the Jacquard score. So A and B are two disjoint sets, and we are looking for the overlap over the total set. So essentially we need a bipartite graph. Now on our small graph, this algorithm runs very, very, very quickly in seconds. But you should note that the complexity grows quadratically with the number of nodes to compare. And this is very good to keep in mind. There are many algorithms out there that you can use, but you should be conscious of their computational and memory requirements, the size of your data, so that you can pick the most suitable one. Now the graph algorithms run over a model which is typically a projection of nodes, relationships, and properties from the underlying graph. And they are stored in memory using compressed data structures which are optimized for topology and property lookups. The graph catalog is basically where all the graph projections are managed in the Graph Data Science library. Now, before we can use the node similarity algorithm, we need to create a projection of the graph that we wanted to operate on. And this is a bipartite graph. So just to refresh our memory, a bipartite graph is a graph whose vertices or nodes can be divided into two disjoint and independent sets. So here we see whiskey and flavor, and every edge or relationships connects a node from the whiskey set to a node in the flavor set. Now here we are doing a native projection for our named projection called flavors, and we are projecting only the whiskey and the flavor nodes along with the flavor relationship type. Then we call the node similarity algorithm and we tell it to operate on our named graph called flavors. We're using two config properties. The first is degree cutoff, and this is the minimum degree of the node to be considered for similarity calculations. So here we are actually just avoiding all whiskeys that have a single flavor. Then we have a similarity cutoff of 0.3. So we actually aren't storing similarities with a value less than 0.3. We're not interested in recommending those at all. So now this algorithm returns pairs of nodes with their calculated similarity score. We're going to write this data to the graph in the form of a similar flavor relationship, and we're going to store the similarity score as a property on this relationship. And it really helps to materialize these calculated similarities in the graph for easy, more performant queries later, and especially when calculating similarity on demand can be quite expensive. So you will see on the right there, the shape of the similarity graph. That's really a visualization of all the whiskey nodes and the similar relationship between them. So I'm going to zoom in here a bit to two of those pairs calculated to be exactly similar. So a score of 1. So we can see quite clearly here that they share an entire set of flavors. And so the score actually makes sense. Now we've got to keep in mind that we calculated similarity purely on the basis of the flavor nodes. And that's what this algorithm has given us. It does not take into account other characteristics of whiskey, such as whether they're similarly rich or dry or sweet. And for this, we'll use another way of calculating similarities a bit later. So now that we have the similarities, we can use it to recommend whiskeys. We are going to start at our target user called P. If he or she is a person in the graph with the label reviewer. We want to find all the whiskeys that he or she has reviewed with a rating of more than 3. Then we're going to look for other whiskeys which are similar to those. Make sure that he hasn't reviewed them before. Make sure that the similarity score is at least 0.4. And then we're going to order them more similar first, cut it off at 5. And we're going to write a recommended to relationship between the person and the whiskey and capture the date on which we recommended it and also the reason, which is flavor similarity, because later we're going to see different types of recommendations and we would like to know which recommendation came out of which algorithm. So for Franta, the recommendations produced by the flavor similarity show some of the peated ones, some of the smoky ones, some of the floral ones, and I know thanks to Franta that he actually does like 1 or 2 of these, so not bad at all. Why were they recommended? So this is our explainability concept, right? We want to be able to go back and say why we recommended this whiskey. So if we actually go and expand the recommended whiskeys, we will find that they have the similar flavor to the whiskeys that Franta reviewed and rated quite highly, so 3 and above. So you can go back and just look at it, and it makes a lot of sense, right? And then we can go one level deeper and say, okay, so did the Talisker 18-year-old actually have anything in common with the Lagavulin 16? And you look at it and you see that yes, they did. They did have the orange and the brine in common, and from the other side you see the toffee and the honey in common, right? And that's what we wanted to achieve with the flavor overlap. Right. Okay. So let's switch a bit and try something else. So we're going to look at collaborative recommendations now. So the basic premise of collaborative systems is that if users have shared the same interests in the past, so they've rated the same whiskeys, for example, then they will have similar tastes in the future. So if two users have had their whiskey preferences heavily overlap in the past, if one of them buys and likes a new whiskey, the system will recommend it to the other and predict that he or she will also like it. Now, user-based approaches can be significantly challenging when used on very large graphs. So when we're looking at tens of millions of users and items, and the feasibility of computing these predictions in real time decreases. Specific user preferences are also not taken into account. So in the example you'll see next, we would actually miss out on cases where it's more significant when two users agree on a controversial choice, because we want to actually amplify this prediction. Or the users that rate whiskeys in a particular way because there's a characteristic of that whiskey that's important to them, but it's not the reason for other users rating it similarly. So that's why this method essentially can be used in systems where item features are not readily available because they don't depend on the features of the items. Now, finally, the prediction quality can be low when the data is sparse. So when there's not enough ratings, for example, the quality can be low, but when there is sufficient data, then it can actually help users discover new interests. This is a bit different from the content-based. Okay, so for collaborative recommendations, we are looking at the user item matrix, right? So given user item ratings and an active user, we want to identify other users that have similar preferences to those of the active user in the past. And remember that this assumes that user preferences remain stable over time. Now, item-based also predict how users will like or dislike items because of the similarity between the items and not the similarity between the users. But both of these are graph analysis problems, making use of paths found between items and users. Now here's our user item matrix. So we see a couple of users in there. We have Pavel, myself, Michael, Vince, couple of whiskeys that we all rated. And even without doing further calculation, it looks fairly clear that Pavel should be recommended the Kalila 12, right? We can see that all three of us rated, he hasn't tried it yet. So seems logical that we should recommend this to him, and there are high chances that he would drink it with one of us anyways. So to calculate, how do we calculate this? So how similar are users in their reviews, right? We are going to use Pearson correlation here. Now, as I said earlier, there are quite a few algorithms to choose from, but understanding the shape of your data and what the algorithm focuses on is useful to know which one to try. So analysis has shown that Pearson correlation outperforms some other methods of comparing users. And that's what we're going to use today. So this is opposed to like cosine similarity being better for items. There are also other ways of calculating similarity. So in some cases, the adjusted cosine similarity can do as well as Pearson. So again, I encourage you to experiment and pick what suits your domain best. So in our query over here, we again start with the same premise. We want to find people that have reviewed at least 2 whiskeys, right? So that's the minimum criteria. We want to find all the whiskeys they've reviewed, and then we want to create the equivalent of the user item matrix over here, but this time in the form of a vector that we can provide to the algorithm, right? So you see that we collect the ratings for reviewers, so for users and their whiskeys. Then we collect them all so that we have the global data set, and we supply it to the Pearson correlation algorithm. That's our data. Again, we have a similarity cutoff of 0.3. What we get back is the 2 items and their similarity. And similar to before, we simply write this to the graph. this time we are writing a similar user relationship between both the users. Okay, so this helps us say which users have similar tastes. And now that we can find similar users, we are going to write our recommendation query, our second recommendation query, or a third one actually, to recommend items to other users. So we start with our target to user, called user in this query, matching the ID. We find all users similar to that particular user. We find all whiskeys that they've rated with at least a rating of 3. And we make sure that the user hasn't already reviewed that whiskey. We order it, we limit it, and we create our recommended relationship. And as you see on the right, indeed, as we imagined, the Kalila 12 was indeed recommended to Pavel. So I guess, Pavel, that's a sign that you should be drinking this whiskey. Right, so we've seen this form of item similarity, user similarity. Before we saw the item similarity where we used only the flavors of each whiskey to calculate node similarity. But this isn't enough for us. There are other nuances of whiskey that are very important when predicting a rating, such as the cask, which imparts a lot of flavor, the sweetness, the richness, the smokiness of the whiskey, or even the region that produced it. Now, for this, we can use node embeddings to compute vector representations of the nodes, and specifically, we will use node2vec for this today. This is based on random walks in the graph. Now, what does this particular node2vec algorithm accept? So again, we are projecting various dimensions of our graph for this algorithm to operate on. So we are projecting all the nodes that we're interested in. So the cask, the whiskey itself, we're gonna add the flavor back into it, but we're going to add other characteristics such as the body, the richness, the smoke, the sweetness. These are all values that we've extracted, and they run on a scale of 0 to 5, 0 being not smoky, not rich, not sweet, all the way up to 5. Whether it's chill filtered or not, the category. And then we're going to project each of these relationships. So we know that from the whiskey to the flavor, we have a flavor relationship. From the whiskey to the cask, we have an aged in cask, and so on and so forth. So these are the nodes and relationships that we are going to project and supply to our node2vec algorithm. And we're going to instruct it to do 10 iterations of the whole thing, do a walk length of about 10. And these are parameters that you will end up playing with to see how best you can get a good vector. And then we're going to write these embeddings as a property on our whiskey nodes. And the property is going to be called embedding on node2vec and T1. So this is our first version, right? So once we run this, if we inspect our graph, we will see a vector, so an array of numbers which represent the embeddings produced by this particular set of characteristics we chose for our graph. Now, pretty much the same as when we calculated the similarity between the users. Here, we're going to use the vectors produced by the node2vec as input to cosine similarity in the graph data science library. So we get a score and we create the similar item relationship between both the whiskeys, right? So again, we match all whiskeys in the graph, we calculate cosine similarity, and then we merge in a similar item. And now that we have this, we can simply use this as we did before. So we can find the highly rated items, and then we can find the items similar to those, make sure that the user hasn't already reviewed them or tried them, and send them back, right? So an example of what that query produced for me earlier is it found these two items it found them to be actually very similar. And we see here that they definitely share 3 of the flavors. And remember, we projected the flavors. We wanted them included in our embeddings. And if you have a look at the properties and the panels on the right, so you also see that they share common or close values in terms of their richness and their smoke and the body, etc. Right? So yeah, fairly similar. But then on the other hand, we find this pair, which was also similar, right? So we have these two whiskeys here, and the only thing they have in common was the sherry finish cask. So these are some of the caveats of the embeddings, especially because the graph that we're operating on isn't very connected, and because Node2Vec works on walking the graph. If you have mostly a disconnected graph, you could end up with things like this. And this is why it's really, really important to understand the characteristics of, or the shape of your graph itself and the underlying algorithm, and match them up, try them up to make sure that you don't overlook things like this, right? Okay, so these fall into like our standard categories of content-based and collaborative recommendations, right? But these are not the only two avenues you have for recommendations. So how about some personalization? So we find quite commonly, at least in whiskey drinkers, that there are people quite a lot of people that fall into the category of liking a lot of smoke or no smoke, right? And they don't like the whiskeys with very little smoke. It kind of just underwhelms them. So these are personas that you can find in your data set. You can calculate this and you can mark these people with a property or a label. And then you can have special recommendations for personas like these. So in this case, we're going to find, we're going to recommend different whiskeys for people that lean towards the heavily smoked category, right? And they wouldn't like anything lightly smoked. But we have similar flavors, right? So here we are trying to broaden the horizon of what people might like to drink. So they're not completely out there, but they share flavors, but we just dial down the smoke all the way to 0 and suggest these whiskeys to other users, right? So we see in this particular graph that the whiskeys that have been recommended here share the flavor profile, but no smoke. And we actually find this in Franta's graph, for example, where he has a good balance of very smoky whiskeys and then not smoky whiskeys, right? And then you have people that like, the middle ground. So they shy away from anything without smoke, and they shy away from very heavily smoked whiskeys. And here again, once we are able to identify these sorts of people, then we're able to tune recommendations for them. So apart from all the previous kinds of recommendations that we could give them, there are some of these that we want to insert into their recommendation list to provide them with something new to try. So here we see very similar queries, right? So all recommendation queries, once you've calculated similarities and scores, they're just a matter of figuring out different paths you can traverse or different parameters that you can dial up or down. So we're using our similar flavor, and we're making sure that the smoke is definitely under 4, right? So the mid-range smoke. And our subject for this particular experiment was Sunny, and we know for a fact that this is the profile he falls into, and the whiskeys that we recommended to him are actually the ones that he likes. So pretty good and pretty neat. Then we have other kinds of factors, right? So tastes, they change or they evolve over time. Now, the drawback of the previous methods is that they assume that the tastes or preferences remain stable. Let's look at this example. So we are looking at Aldrin over here, and we read from left to right. So this is the order in which he rated whiskeys over time. So reminder that the ones with the blue badge were the smoky C flavors, right? So they start very, very clearly in the smoky range. But then over time, you see the pink ones that show sort of a graduation towards no smoke. They move towards the delicate and the floral kinds of whiskeys. So we want to take this into account. We don't want to ignore the fact that perhaps taste is changing, and we want to start making guesses into, is the user's taste really changing maybe we need to recommend more like what he drinks currently rather than stick to, what he drank in the past and maybe isn't interested in drinking so much nowadays. So if we wrote what I would call our standard normal recommendation query, right? So we match the reviewer, in this case, Aldrin, all the whiskeys that we reviewed before. We go through our similar flavor relationship type. We find ones that match it and we return them back. So this is like a mix of smoky, non-smoky, rich, delicate whiskeys, all of them in one, they don't take into account time. But now we can change this query a bit, so we can weight it by time and now detect that potential switch or that progression of taste into more floral ones. And we start to surface these slightly more floral whiskeys at the top of our recommendation. And we measure to see if the user is actually interested in them or was this like a one-off, right? So taking into account changing taste over time, I think is quite important and keeps the user engaged. Then we have serendipity, right? So the accuracy and recommender system. So when you start out, accuracy is important, or the irrelevance of the recommendations just drive people away. But then it begins to get boring. So would you like to listen to music from your favorite artist all the time? Would you like to drink more of the same whiskey? So probably not. We like to be surprised in pleasant ways and discover and appreciate something new. So something that we didn't set out to find. And this is very important in recommender systems as well. It keeps customers interested. It makes business sense as well, right? To offer diverse recommendations, potentially sell into new avenues. It is hard to measure. So serendipity can be introduced into in many different ways, and it differs completely from domain to domain. You might want to recommend across a wide range of choices. You might want to recommend something new, something unexpected, but still with some thread of connection to the user so that they're completely not out there, like the aquarium cleaners. So earlier we calculated similarities between whiskeys based on flavor. Now we can project a graph containing those similarities and supply to the Louvain similar community detection algorithm. So this Louvain method is the algorithm to detect communities and large networks, and it evaluates how much more densely connected the nodes within the community are compared to how connected they would be in a random network. So we calculate this community and we write that number as a property called the Louvain flavor on the whiskey nodes. And when we actually visualize this, this is, for example, one of the communities which has similar kinds of whiskeys. So what can we do, right, to introduce this level of surprise or something you didn't expect? From time to time, we might actually recommend a whiskey from a region that the user hasn't tried before. It won't be completely out of the blue because we will do it from communities that contain whiskeys that he or she likes. So by now you're very familiar with this sort of query where we find users, we find the whiskeys that they really rate highly, but now we're actually going to pick other whiskeys from the same community as those, and we are going to we're going to filter out whiskeys from a region that the user has tried before. So what this shows us is that Michael actually has plenty of whiskeys to try from different regions here, like Highland or Speyside. Always recommending things that best fit into the user's current neighborhood in terms of similarity can quickly hit this problem of redundancy, because you'll have the same items recommended over and over again with very little variation. Now, in some cases, it might be best to boost these weak ties. So recommending such a new item, which if it were accepted, would create a bridge between these strongly connected subgraphs. And they can enable recommendation algorithms to actually start to reach the unexplored parts of the graph. So this also provides an element of serendipity, allowing users to explore new things. And this is, as you see in the link on the previous slide, this is from our blog written by Miro, and he calls it the NOT recommendation. So this query finds whiskeys with similar flavors to the ones liked by Tony, but then it filters out those that have been reviewed by any other reviewer who's similar to Tony. It also excludes any whiskies that were reviewed by people that reviewed the same whiskies as Tony. So this kind of breaks out of Tony's circle and perhaps brings in something novel from weekly related networks. So finally, we need to put this all together into a recommender system. So we have in this diagram the items analyzer, which processes features of the item and results in an item profile that is persisted in permanent storage. User profiles are built similarly with explicit or implicit input. The recommendation engine uses these models to produce the list of recommendations, and this itself uses many different recommenders. So essentially, we're always looking for a hybrid system that uses the best content, collaborative, context-sensitive recommenders, as well as all the things that come with recommendation engine, so filters, blacklists, score boosters. And finally, the loop is closed by taking into account user feedback to constantly evaluate the effectiveness, tune, and improve the recommendations. So graph-based approaches shine, as we've seen today. User item data sets can be easily represented as bipartite graphs, and the same graph model was used to extract different vector representations of users and items. Pathfinding was very efficient. So I hope this gives you a taste of all the dimensions you can use while recommending items using graphs. And this is really just the beginning. There are plenty of interesting queries to try, algorithms to explore, theories to test, but best of all, getting started to produce recommendations with a graph is really so easy. And before I end, I have to say special thanks to all my whiskey-loving graph-aware friends and friends of friends who patiently rated whiskeys for me, tried out the recommendations, filled out many forms. And of course, it's been really my privilege to be able to consult our chief scientist, Alessandro, read his book, The Graph-Powered Machine Learning, and he provided advice on all the embeddings that you saw in the slides earlier in my presentation. So thank you, Chief. And with that, that is the end of my talk. I hope you enjoyed it.
Very cool. I feel like that talk was aimed at my husband, who loves his peaty whiskies. We keep talking about going to the annual festival that's on Islay, obviously not at this very moment in time, and the whiskey tours. So, Luann, have you been chatting to Pete by any chance? So Luann will be with us shortly. So whilst we are getting that sorted, put your questions in the chat. Hello.
Hey there.
How's it going? How are you? Happy Nodes Day.
Yeah, thank you. It's a great day. We've been looking forward to it. I know a lot of people at GraphAware are watching today as well, so it should be a fun day.
Excellent. I think there might be a bit of a problem with your audio, so I don't know if you can try disabling it and re-abling it, see if it'll...
Okay. Okay, does that better?
Not quite. Could you try... We've got two options. So yeah, maybe you might need to exit and come back in again. And Alex, you're on mute, so...
Okay, I'm going to do that.
Audio fun. I don't even know if people can hear me.
I am going to do that. I'll be back.
Thank you. No, you're still on mute.
All right.
There you go.
Oh, okay, cool. Yeah. So Luann is joining us.
Yes, so she'll be here shortly. Yep. So it'd be really cool. So have a bit of fun. We shall ask some questions. So cue your questions in the chat.
Yeah, we had a couple coming in. So I think we can talk about these, and then we see.
Absolutely.
Luann back. Let's see how it goes.
And just for a bit of fun, just ping in the chat if you're a whiskey drinker. Just chuck in just for just an
your favorite whiskey.
Just put in your favorite whiskey. Why not?
Yeah. Welcome back, Luann.
Welcome back.
Thank you. Is this better?
Oh,
yes, this is perfect. Yes. This is great.
Good.
Yes.
Yeah. Good. Okay, because I wouldn't know what to fix next, so that's
that helped. So yeah, thank you very much, Luan. You are the VP of Engineering at GraphAware, one of our dear partners at Neo4j, collaborating for years on various projects around the globe. And yeah, thank you for the presentation, and thank you for joining us this day for our Nodes 2021 warm-up show.
Yeah, I'm happy to be here. It's a fun day.
So we had a couple of questions on your talk, so maybe we can dive in right there. But maybe before we do that, do you wanna say a sentence or two about yourself, who you are, what you're doing?
Yeah, sure. So yeah, thanks for the introduction. Of course, I work at GraphAware. We've been doing Neo4j for forever now. We probably have like one of the largest concentration of Neo4j expertise out of Neo4j at GraphAware. So we really love graphs. We love making our customers succeed with graphs, connected data problems. And I think since the time we spoke last, we launched our own product called Hume, which is a graph-powered insights engine, and that's been doing really, really well. We continue to be really excited about the future of Hume and really how it helps our clients. So yeah, that's me.
Cool, thank you, Luan.
So probably something worth mentioning as well. Actually, I'm going to ask this question. Now, we asked it last time, but I thought the answer was so fun. I'm going to ask it again. Alex knows what's coming. So, how long have you been using Neo4j for?
Yeah. Okay, so let's see. We're in 2021. About 12 years now. Yeah.
That is. Yeah. At some point, you need to get a special badge of honor.
Yeah. Yeah, that would be cool. That would be cool. Yeah, it's been a long time, but not tired of it yet. I really do love Neo4j and graphs, so it's amazing.
Cool. Absolutely phenomenal. So I think go for it.
Yeah, I think you probably more or less answered this a little bit already in your talk, but maybe we use this as well. So there was this question from Kim, interested in knowing if there are any hypothesis testing involved in feeding back on the decisions of the domain expert data scientists in your.
Okay. Yeah. So well, for my talk that we just saw, yeah, there were some experts, all whiskey drinking experts. They were real people. They all work at GraphAware or did work at GraphAware. So they really were, I'm sorry to say, my guinea pigs for this talk. We ran the recommendations. We had feedback from them previously about what they drank, what their likes were, dislikes were. We did some of the queries. I had help from Alessandro to tune them a bit. And then we kind of ran them back against the set of people to see, whether they were completely off or whether they were pretty accurate. And they were in most cases. So of course, this graph was pretty small and our user base was tiny. But it was a very good start. So definitely we did some of this for this particular talk. In some of the other graphs that we do, knowledge graphs that we do for our clients, we try to build in feedback loops to understand how close the recommendations are. And then in some cases, maybe you can take direct action to improve the quality of that recommendation. And in some cases, it's more of a manual process, but it's definitely very, very important. Otherwise, you could get really inaccurate recommendations and everybody hates that.
Yeah.
Quick question on this. So you obviously got the feedback from your whiskey drinking colleagues to build this graph. Did you put it into practice? Did you then generate some recommendations and make them try the recommendations?
We did. So all the people that you saw there, they all had recommendations. I don't actually know. While watching myself being played back today, I was actually thinking, I need to actually check if they really tried them or not. But they were very, very real preferences and very real recommendations. I don't know if anyone bought them, but it's on my list to check back when I get back to work.
So cool.
So cool, yeah. How many whiskeys did you drink during the making of this video?
I don't think I should answer that.
All right. Next question was, and I think you probably answered this already also, is what tool is used for the visualization?
That's Hume. Yeah, that is indeed Hume. And yeah, I guess that's the answer to the question. But if you like to know more, then let me know.
Yeah, actually, could you talk a little bit about Hume? So I know you gave a brief introduction, but can you talk a little bit about how does that sort of fit in with the whole sort of solution pipeline?
Yeah. Okay. So Hume is really, of course, it revolves around Neo4j under the covers, right? So Neo4j is the graph that powers Hume, and we look at it really as a platform or an ecosystem for extracting insights from your graph. So there are a couple of focus areas for Hume. One of them is, of course, the visualization that just came up. So this is really powerful because we try to abstract away the need for analysts to learn how to write code or learn how to write complex queries. So we do follow a bit of the low-code approach where you are able to surface these insights or patterns directly to users in a really, really easy way. So building this knowledge graph, you can be up and running in like under a day to ingest your data, write what we call Hume actions. So you can encode your patterns into an action and then analysts simply run them, right? So that's the visualization component. And then we also have another component called Hume Orchestra, which is really how we actually loaded data into the Whiskey graph. And what it does is it's not just an ETL tool, right? There are plenty of them out there. But it really helps you connect a lot of sources. It helps you plug in skills to extract, entities from unstructured text. It allows you to connect to other services that you might have running to enrich your data. And this has been really successful because apart from having, to get your data into the graph sometimes is one of the biggest stumbling blocks. So we have Orchestra to help you do that. Once your data is into the graph, then you have the visualization that people can play with and try and extract insights from it. We are leaning heavily towards more, now that the data is in the graph for most of our customers and they've kind of moved on from why use a graph to actually extracting insights from it, the focus of Hume is now shifting towards providing those insights to analysts, to data scientists, people that really need to understand their data. So tools such as, snapshots of your graph in time so that you can come back and start off from where you left off. We are working on alerting at the moment, which is really cool because your graph is like constantly evolving and changing, right? And you can do it the manual way where you kind of, log in the morning and query your graph and see what's changed. Or you can set up, automated alerts, which will sort of monitor the graph and then alert you to whatever it is that you're looking for. So that's really cool. That's coming up in our next release, and we're super excited about that.
So almost like an advanced trigger. So it's not quite a trigger where. So is it the right assumption? So obviously, yes, you can put trigger in a database, and if a specific thing comes up, but I'm guessing this is more. This is like a term or a pattern of things, something that should.
Yes, absolutely. Yeah, it's definitely more than a trigger. So it's you can do things like monitor certain entities in the graph, right? So maybe you're not interested in everything that could possibly change in your graph, but a couple of focused target entities. You want to know if new relations have appeared between them. You want to know maybe if they're deleted. You want to know if someone has modified them. You want to understand maybe whether a new pattern has appeared in your graph. So it's not necessarily like a single hop relation between two nodes, but you want to check that. So completely wild example, whether there are new people drinking whiskeys that come from Islay with a rating of 5 and above, right? So that's fairly large pattern. So you could do that with alerts. So it's much more than the standard database triggers.
Super cool.
One more question came in from Simon. What would you do in case of no real user data? Would you build random user generator? I mean, what can we do if we don't have a base of data to use? It's difficult.
Yeah. This is kind of difficult. So, so if you don't have the users, and it's really going to be hard to do recommendations based on similar users, because you just have none, right? So in this cases, what a lot of recommender systems do is they, of course, everyone has the problem of how to attract users, but when you do attract them, then you still need to provide recommendations which aren't really based on previous users, because they don't exist. And that's the example from my talk from last year, where the next best thing to do is to come up with a safe bet of recommending items based on some characteristics, maybe how popular they are, or how new they are, or whether they've been reviewed elsewhere with like good results, and try and push those out as recommendations to new users. And then if they're good enough, then it sort of builds up your user base, right? And then you can sort of get into the area of finding users that are similar to each other, and then do those sorts of recommendations. But otherwise, generating users for the sake of recommendations, I think, would be, in my opinion, a bit dangerous, because that effect would sort of multiply. If you have recommendations that weren't really accurate, you're kind of just going to multiply that over time, and probably, would do more harm than good, I would say.
And I think that actually dovetails quite nicely into one of the questions that's popped up, which was from Chrome about how can you measure bias? And I think to some extent, it's like the opposite side, which is how do you avoid introducing some bias into the first place as well, which is obviously going to be a key point of like measuring the bias, and how do you stop bringing it in the first place? So, but yeah, I'm going to shut up now. And how can you measure bias?
Yeah. This is a really tough question. I am going to be like completely honest and say this is a bit out of the realm of my expertise. So I would actually encourage you to maybe talk to people like Alessandro from GraphAware, who of course has written the book, but this is more of his area. So yeah, I wouldn't be able to answer this question very well.
Totally fair. But as sort of Chrome's pulled out, yeah, it is something to be aware of. You want to understand what you're putting in, how you build your model, because we talk a lot about, as one modeler to another, we talk a lot about how graph data model is very close to the domain you're working with, and it's a natural fit. But obviously, the dark side of that is you make assumptions about how things are connected in certain situations. And just at that level, you're potentially putting biases in, and it's just sort of having that awareness. And yeah, it can be anywhere. So
yeah, absolutely. And that's why also, slightly connected to this is the whole area of feedback, right? So to actually know whether, apart from you recognizing that bias, is to really measure to say whether you've, subconsciously introduced that in some way or another. And so I think feedback in some respects do help to kind of surface things that you didn't know were sort of just there. And then you can take corrective action. But to prevent it in the first place, I think it's probably quite an extensive field to, examine in more detail.
Absolutely. Oh, very cool. Thank you.
Yeah, cool. Let me see. I think that don't see any more questions. Oh yeah, there's one more here. Can you interact with the graph via the visualization? If you want to say that,
yeah,
do not
course.
like the yeah.
Of course. So in Hume we do this with actions. So we use actions for a lot of things, not only to sort of bring more data onto your canvas from your underlying graph based on query or what you're looking for, but also to write back to the graph, or maybe in some cases another graph. So to provide to say you don't like a recommended whiskey, so what we would do in Hume is to really create an action for that.
which is currently backed by a Cypher query, and you would you would right click on the Whiskey node and then say, I don't like this. And what would happen, of course, this really depends on what you're building, but if I did this for the Whiskey graph, then I would probably write a Cypher query that would kind of mark that node as, don't recommend this again, or really a very, very negative feedback because we've recommended something and you don't really like it. And then from there onwards, there could be a couple of ways to go about it. If you kind of find that the amount of items being recommended which you don't like are fairly high, then we should probably go back and examine why we recommended it in the first place. But in some cases, they just one-off, and you would make sure that you never recommend them again. So yeah, to go back to the question via the visualization, you can read and you can write, and you can do a lot of path-based operations. You can do virtual paths. You can have virtually computed attributes, a lot of stuff. It's a very cool visualization.
Absolutely. And actually, probably slight change of topic, because you are one of our speakers later on today at Notes.
Yes.
And you are covering a subject that has tripped many a novice and experienced alike. So would you like to tell us a little bit more?
Yeah. It's a lightning talk, so it's going to be really, really fast. But it is about merge, and I know it's a strange topic to propose for a conference, but I think it's really relevant because ever since merge, ever since merge was born, it's a very powerful. It's super powerful, and it is very straightforward if you actually understand the fundamentals behind it. And what happens is those little tricky areas are not well known, and we see like a lot of questions around it. So this is probably the reason I actually wrote the blog post about it many years ago, and it continues to be popular, which is really strange. And I see a lot of questions on Stack Overflow and a lot of questions, in the Neo4j forums. It was one of those questions that actually where somebody answered it by pointing to my blog post, and then I was like, okay, you were looking for proposals for Nodes 2021. I was like, this is a good topic, why not? So what I plan to cover is really what are the key things you need to understand about merge, and once you know it, there is no way you can go wrong. But yeah, I do admit that I do a lot of trainings, and these are my favorite questions, trick exercises to run during the trainings, because the amount of people getting them right is very, very low. And so it kind of still tells me that merge is this area that you really need to understand well to use it effectively.
Yeah, I feel like merge is the was it the Superman phrase? With great power comes great responsibility.
Yeah.
And I feel like if you wanted to pick one of the Cypher commands that probably fits that phrase, I think merge is a good fit.
I think merge would be a good fit. Yeah, you're right. You're right. Yeah.
Oh, fantastic.
That's cool.
So I think a few people are asking when Lightning Talks. So we've the setup of the blocks. So we've got the Lightning Talks in the second and fourth set of blocks. So I'm going to quickly consult my. Oh, sorry, I accidentally pressed Zoom on my thing. So for those of you who are keen to come and watch Luann's talk, she is on at just again, so 2:30 p.m. UTC. So you'll be able to check out the talk then.
Exactly. Thank you. So that's all later today. I mean, I can't let you go before you give us your highlight besides your own talk, obviously, for Nodes 2021. So is there anything particular you marked in your agenda for later today to watch as a must see from your side?
Yeah, there are two talks that I'm really looking forward to. One is the BASF talk on what is it called? The local and global graph traversals. I hear they have a huge graph, and I'm really, really looking forward to this one. The other talk is from Mike on modeling physical systems as a graph, I think. So I think those two are definitely up on my list, and I'm hoping to catch at least one of the link prediction talks today. So we'll see how that goes.
Yeah, excellent talks.
Super, that's interesting. Well, with that, I think, yeah, thank you very much, Luan, again for joining us today. You are becoming a regular guest on these sessions, but it's always great to have you. So really, really thank you for taking the time again,
No
being
problem.
part of it.
Thank you for having me.
Yeah,
and
thank
good
you
luck
so
with
much.
the rest of the day.
Thank you.
Have an amazing conference.
Thanks, you too.
Thank you.
See you
Take
later.
care. Bye-bye.
Bye-bye.
Okay, that was cool.
Always cool. Always cool. That's it's really interesting as well. Hume is such a cool tool, so that's always great to see it being applied in these fun situations as well.
Absolutely.
And if nothing else, I think we have a few more whiskey experts in the audience.
Yeah, I mean this is a little bit dangerous, right? I mean, if you need up your sample size, you need to drink a lot of whiskey. So
down your sample size, surely.
It's probably yeah.
You do that terrible thing when they spit out the alcohol that they're tasting, and you're like, no.
Yes, wine in particular, but also I guess with whiskey, yeah. All right. I mean, looking at the time, we have one more track to introduce before we go with our next two guests, Anthony and Alex. So maybe quick rundown and a short reminder again: what is Nose and what is to be expected today. So it's our developer-focused event with really lots of developer content throughout the next few hours. We have 5 tracks, 50 different talks. Almost all of them are live. So during this warm-up session, we showcased a couple of the favorites from our guests and from us as well. So you have lots to pick from. Don't fear if you think, oh my God, and we had this in chat as well. There's so much fear of missing out is big with this session today. Everything will be recorded, obviously, and everything will be available afterwards as a video on demand. So to pick your agenda, pick the one you are interested in most, and if there's some overlaps, don't worry, you will be able to watch them later on. What else is there to know? There is a closing keynote with Jim Weber and some members of the community as a panel discussion. So that's going to be fun towards the end of the day. And if you want to interact with anybody during the day or afterwards even, please join us on Discord. Use on Twitch, use !Discord. Anywhere else, just type dev.neo4j.com/chat in your browser and you will be directed to our Discord channel. There you can interact with the community. It's a fun and nice place, open to anybody and all skills welcome. And if you're there, don't forget to type !notes in any chat window on our Discord server in any channel, because then you get access to our Notes 2021 voice and text channels where you can then do more interactivity with the community.
And we're going to do some demos on that as well shortly as well.
Oh, some demos. Yeah, that's cool. Let's check out the track. Before I go into the track, or we go into the track, we have our community partners to thank for Notes. These are the selection that made making Notes happening and help us make it happen. It's really great to have such a wide range of community partners jump in and say, "Yeah, sure, I'm helping out. I'm happy to support," and this is really great. Thank you all for doing this. Yeah, and this is the apps and APIs track. So we have another set of nice and interesting talks coming up in this specific track.
So yeah, it's as the track title gives it away, it's all about applications built with Graph and APIs for connecting you with the Graph, and sometimes it's all of the above put together. So there are some, all of these, I'd like to point out across all of the tracks, these are all exciting talks, but here's some exciting talks. Exciting talks. So you've got the one about combating medical climate crisis. So again, looking at building out a knowledge graph to deal with antibiotics resistance. So this is something that is a real big issue we're seeing around the world, where the amount of antibiotics available for us to fight bacterial infections are coming down, and what can you do to build a graph to build a knowledge graph to combat that? The next one, I love this. Why not do your Cypher queries with voice? So And it has been inspired by Star Trek, so I think that's going to be a good bit of fun there. The next one, so actually this is with Michael Bender. So David Bender, we did an interview with him on one of our podcasts. So he basically has built out an API for Neo4j and Python. So building on top of the Fast API, he's built a Fast Graph API. So he's going to be talking about how he built that, how he put that together, and how you can get involved if you're interested in that project. And then got this one. I think this is more up your street, Alex. So this is effectively, was it the advent of Epic Games and MetaHumans? So this is where he's building in. So I think a lot of computer games are built on top of Unreal engines.
Yep.
So yeah, it's going to be quite interesting.
It's going to be interesting. Yeah. Unreal Engine is a big major big video games. Unreal Engine is sort of the one engine that makes it look good. It's very capable of high-end graphics. So it's a very cool tool set, I think. So this is going to be interesting. Yeah, it fits.
Yeah, no, I'm quite excited to see how that all pieces together. The next one, so Dreamweaver. This is all about, again, sort of another theme of this sort of a knowledge graph of sorts. So effectively, they're doing a massive bulk import of the millions of, sort of like the hundreds of millions and billions of relationships that you have. You think about the genome and how things are connected. So effectively pulling all of that together and seeing how that enables further research. So again, another potentially big graph we're looking at here as well. And then the next two talks, so the APX RegTech knowledge graph and our journey from test automation to a data marketplace. So the really cool thing about these, so a lot of you are aware of Aura, so that's our cloud service. We've got Aura Free coming just around the corner, so you definitely want to be tuned into the keynote to find out more about that. So we've also got our Aura Professional tier. So that was our first cloud option that came out, and these are great stories about how these two companies are basically using Neo4j Aura. So how have they transitioned, how have they built it, what they're doing with it. So definitely if you are, if you're looking at cloud first options and that kind of things, those are two talks to check out. Then we've got involving graph enterprises. So we've effectively talking about the lessons learned and stories from Dell, what they've been doing, how they've used those things, what they learned, what elements of the Neo4j Graph platform are in play at the moment. One that's close to my heart, what can I say? So some of you may have been watching, last year I was doing a lot of exploring a wine data set. So when I saw this one come in, I was like, so yes. So effectively, so this is a commercial search engine where effectively they do lots of different things. So probably not that dissimilar to Luann's talk about how do you do WastScale recommendations. So here, like all the various elements around wine and being able to do that kind of recommendations behind that. So very interesting. So they're going to talk about the architecture they've built out, the data pipelines involved. So that'd be pretty cool. And
seems to be a common topic.
Hey, you got a drink at some point. We need to do a tea one. We need somebody to come and do the sort of like the anti-alcohol bias one where we do like some tea and soft drinks.
You should talk to Joe. I think Joe is a big tea connoisseur, almost. So maybe he can be convinced to do something on tea.
Oh, absolutely. And the last talk in this track is effectively. We have a lot of stuff. So there's been a lot of content around sort of hooking up with Java, GraphQL, which would be via the JavaScript drivers, sort of Python and things. So I'm really pleased that we've got something talking in the .NET universe. So yeah, effectively, they're talking about how they've built out Hot Chocolate. I think Priya mentioned this talk earlier. So yeah, it'd be great. And sort of coming from a .NET background myself, always great fun to see. So I think. What does Adam say? He brings the antidote to the Java push. So yeah, we'll get a bit more around .NET and the Microsoft universe here as well. So yeah, super cool.
Super cool. Yeah, exactly. So that's that overview. How to register to Nodes? Maybe quickly. Yeah, it's very easy. Go to neo4j.com/nodes, and then you will be granted with or presented with a registration form. and there you just then join. You can still do it, so don't worry. Its time is not run out, so you can do it until. I mean, actually, you can do it throughout the day, but I mean, who wants to miss the keynote from Emil? So, right, should do it probably in the next hour or so, if you haven't done it already. How to chat, we just covered, and we're on Discord, right? So don't forget !Discord on Twitch, and you get the link right away. And that gives us the current status. So marking the wrong session here, but you get it. So next up we have Alex and Anthony from our Neo4j community. So I will get them on screen in a second. Let me quickly do that.
Yeah, and hello. Maybe we can do this some other way.
Yeah, this is the first time I've ever seen Alex, actually.
Which Alex?
Here we go.
Oh, there we go.
This is much better. Yeah.
There we go.
Hi.
So, first of all, where are you both based? Where are you dialing in from?
I'm in Portland, Oregon. So it's 4 a.m. here.
Yeah. Oh no, another 4 a.m. What have I done?
Go on for entertainment value. What time is it in Portland, Oregon at the moment?
4 a.m.
No, another 4 a.m.
Yep. And I'm a night person, so I just stayed up.
Okay.
Oh, wow. Okay. I'm sorry. You could have said something.
No, I'm okay with it. Honestly, I love Neo4j, so I'm just happy to be able to help and contribute in any way I can, which is kind of what this panel's about, isn't it?
It is, exactly, yes.
It's amazing. Oh my goodness. That's our third person today that's been up at 4 a.m. Alex,
time zones thing.
For me, thankfully, it's not midnight or afterwards. It's afternoon. I'm based in Berlin, in Germany.
Good afternoon.
Good afternoon.
Oh my goodness. So I guess let's hear a bit about yourself. So obviously you're both very active in the Neo4j community. We'll start with Anthony first, I think, since it's an early start. So no, first. Tell us about yourself. How did you get involved? What kind of things are you doing?
So I worked with a design firm that ended up partnering with a university and a state museum, and we're actually still, as of 3 years worth of a project, in progress of building a federated database, collecting museum archives from around the world, and then standardizing those, curating them, and then pulling them into a graph to power this touch interactive museum exhibit. And all of that is intended to be and is about to become public open source code and APIs and data, including the graph and everything that we're working on. So when I got introduced to that project, they were asking me, how can we best structure this? And the answer was, there's no other choice but a graph. And I looked at a lot of different engines, and Neo4j was the best solution, and the rest was kind of history and me falling in love with the tool.
That is so cool. That is literally so cool. Do you know roughly when it's all going public? And
it was supposed to be a year ago. So I'll let you know when I know for sure.
Oh wow, that is super cool.
Yeah, it's pretty awesome, because what we're doing is building this graph of artists, medium genres, cultures, nations, and across time and geography, and then analyzing, which things have the most number of shared connections. And then you can, if you look at an artist, it'll show you all of the other artists, nations, etc., that have the most number of shared connections via the curated artwork. And so there's amazing cool stuff that comes out of the graph already, and I'm not good at graph analysis yet, so I'm still working on it.
Oh, I look forward to having a play with that when it comes out. That sounds amazing.
You'd be more than welcome to.
Yeah.
What about yourself, Alex? Tell him, yeah.
Yeah, I started working with Neo4j like a year ago, which was actually the time that I also changed jobs, and I'm working in a real estate company, and we are modeling like all the properties and all the data that we use in a graph, which is super nice and super flexible to add anything that comes up, and to also see the relationships and do analysis. For example, for properties, and we have items inside the properties that, for example, we have nodes that are components of the apartment, and what type it's being used, which we can do analysis for that and do upgrades or select components that are better, etc. Which is really nice and really flexible to use with a graph and Neo4j.
Cool, very exciting. That is it's a little bit. Is it a little bit similar to what what I don't know if you watch that, of what Polly is doing with the architecture and the I think she's from different approach probably, but it's kind of like the similar area.
Haven't actually watched that, so
okay.
I'm not really sure.
Yeah, don't worry. I think what they are doing is like also looking into architecture and how buildings are built and all the contract situation that follows that, and then how the setting up of a project like this, helping with graph technology. So I think it sounded a little bit similar, but
a little bit similar, yeah, but different. Probably we use different for different stuff.
Different, yes, of course, yeah.
Mm-hmm.
There's a huge library of lots of different projects and videos and knowledge out there. It's impossible for anyone to know all of it, which is kind of why me and Alex are there, right?
Yeah.
Stay plugged in and try to help connect people.
Yeah, absolutely. It's quite convenient, having a technology that talks all about valuing relationships and building connections.
That relatively accurately models the real world instead of having nulls and rows everywhere that don't make sense.
Yeah.
I'm over hacking tables to try to make sense out of stuff. Like, there's no other way to do things than graphs. It's just that simple.
Have you got to the stage yet where you've got a large enough table of values and you're like, right, I'm just going to quickly just lob that into Neo4j?
Oh yeah, it's my primary tool now. I just pull up Neo4j and like I'll have a CSV and I'll just pull it into the graph and I'll run, organize it however I need it, and boom, I can pull whatever data I want out of it, just like that. And it's easier than even trying to dump it into a spreadsheet because it's all right there at your fingertips. And it's like the minute and a half it takes you to load it into a graph versus into a spreadsheet is just, it doesn't make sense. Why would you put it into a spreadsheet when you could just pull whatever information you want out quickly and easily and beautifully, and just there's no other way to do it.
No, absolutely. And I'm not going to lie as well, sort of an extension of that. So I can be a bit lazy, and even to the extent I've got the data in the database and I'm like, I could write some Cypher queries, but I'll just load up Bloom, and I don't even have to do that bit either. I can whack in some words and just say, yep, roughly. Well, cool, I've answered my question, off I go.
Yep. Now I've gotten good enough with Cypher queries. I don't have to think about how to write it. I just write it like it's English to me now. So.
True.
Yeah, Cypher is really easy to use. Yeah.
Yeah, it's really, really cool.
It's a lot
maybe,
of fun, honestly.
It is, yeah. Maybe talk a bit about the community aspect. So you two are a part of our Neo4j Ninja program. I think Anthony, you are with the program for quite a while. Alex, you joined recently. Could you maybe share a little bit what it is and how what's your motivation and how you feel about the program in general?
Yeah, Alex,
Sure.
I'm curious your take. So go
Sure.
first.
Yeah, because yeah, I actually joined like maybe a few months ago. Mainly through Discord. I'm really active in Discord, and I like that you can communicate directly and live messaging. Yeah, and also that you can join into audio chats for questions and to explain something to someone else, or learn something. And yeah, it was I had already been using Discord, and it was really nice to integrate Neo4j and communicating and join the community through Discord. Yeah.
So for me, I actually joined the Ninja program when it first started, which was about just a little over 2.5 years ago now. And I really didn't know what to expect. I just knew that I was in the forums so much back when we just had the forums that and just trying to find answers to my own questions, that I ended up learning a lot and answering other people's questions. And that's along the way, learned way more than I needed to for my job, but still enjoyed just talking and helping people and learning things and exploring Neo4j, and everything grew from there. And so now it's just when I have time on my own time, I'm diving into Discord and finding what problems I can help with.
Cool, and it's really great, and everybody at Neo4j is very thankful of what you do, and it's super to see the motivation and the enthusiasm you two as an example, but all of the community brings in. So disregarding of you having a ninja badge or no, everybody is very enthusiastic. Everybody is sharing, so it's great, and it's really thank you for doing this.
Yeah, and the whole community thanks you as well. I mean, it's super amazing.
Yeah,
one thing
actually,
that was.
Go ahead.
You first.
No, I just wanted to say that doing this, it's really nice also to learn new stuff. Even for me, that when I'm trying to help someone else, it can be really interesting to. Maybe I don't know the topic, but it's really interesting to learn something new from others' questions and be able to answer them. So I really like that aspect of being part of the community.
Yep. One of the things that I was really pleasantly surprised about once I started to get more connected to the community was just how positive, helpful, and passionate everyone in the Neo4j community really is. And I mean everyone. People that in other tools would just shun the whole public face are there in the trenches with us. And Alexander's one of them. You know, we've got two Alexes, Alexander Ertl. So one of the things that I find I end up doing in the community a lot is that new people to Neo4j will just come and be like, hey, what is this problem? And I'll be like, well, I can't solve that, but message this person directly and they'll help you and they'll be glad to. And it's awesome to just be able to tell people, yes, ask whoever you think is the expert and they'll be there for you. And that's, you know, one of the other fun parts about it. Like Alicia Keys, who built the GDS library. You know, you can find her on Discord and you can message her directly in the community forums and she responds. And it's just the way the whole community is. It's just, we all help each other. We all work well together, and it's just because we love graphs. It's that simple.
Absolutely. Yeah, no, they are great fun, really great fun, and it's a great community to work with as well.
Yeah,
absolutely. Talking about questions, we had one from the chat. So it was from Michael, actually. What are your favorite questions, and what are some of the most tricky questions you answered? So I think that could be interesting. Do you remember anything in particular that stands out?
It's really hard for me to remember specific questions, but there are sort of situations that have arisen that I really enjoy, and that's when I get into this really deep back and forth that ends up needing to, in one case, required a bug fix deep in the GDS library. In another case, we ended up getting 4 different of the Neo4j experts, the other Alexander, and Michael and Alicia, I think it was Alicia, all on the same forum thread, and it went on for almost a month trying to figure out a solution to this big complex problem that at the end shaked out to be like 4 lines of cipher, but it's you know, it's that back and forth, because it's 9 times out of 10 the problem isn't how do I do this, the problem is how do I better frame my question. And so once you can work with someone to figure out, oh, this is the problem you're trying to solve, but this is the data you have, and the problem is the delta between those two. Let's fix that delta, and then it's an easy query to make. And those are always my favorite questions, and that's just because it is thinking through the complexities of graphs and teaching people how to think in graphs, I guess, all at the same time. That was a really roundabout answer to that question. I don't have a good answer to that question. That's the best one I got.
No, that's great. I think that's a good example. You know, the community working together, and then in the end fixing a product issue. Is the best that can happen, really. Yeah.
For me, I don't have something specific in my mind. Usually, it's I hang around the Cypher and Epoch channels mainly, and I really like questions that I'm not really sure what the answer is, or I don't have the specific. I don't know the specifics of how to do it, but I know enough so I can search to find what is needed to complete to find the answer. Those are the most exciting for me, and also there are topics that I'm not really I don't have experience in, like data science. So from time to time, I just hang around there and get some experience from looking into the answers, which is really nice.
Yeah, I didn't even know what graph projection and virtual graphs were until like a couple months ago, solving a few problems.
Yep. Same here.
But it's fun learning as I go, and I think a big part of the deal is just, again, knowing who to ask and knowing where to find how to find the answers is one of the biggest problems when you're approaching Neo4j or graph databases in general at first. And so, you know, having, I guess, noobs who've been learning for a while there to help you and who already have encountered those same questions, or at least know where to find the answers quickly, that's just what we do.
Yeah.
Absolutely. Oh my
I wouldn't
goodness.
call any of us noobs, though. I mean,
it's always a learning experience. Yeah. You have to start from zero. So
yeah,
it's the Socratic, you know, assume I know nothing kind of thing.
Yeah, and the thing that's really interesting about this as well is that you take for granted sometimes when you've spent amount of time on something, you take for granted that you've unconsciously learned. You do ABC, XYZ, you do ABC, you avoid EDF, blah, 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 blah. And I think sometimes, you know, it's really valuable to get that viewpoint from somebody who is completely new, because sometimes, you know, just miss stuff. You know, oh, it's not obvious to me that this actually is an obvious thing that should be resolved or fixed, or this is an obvious way you learn things. And all of it is super valuable insight, sort of bringing all of that story together.
Yeah, absolutely.
So I guess I'm always quite curious, and I love asking this question because we've had some really interesting sort of answers coming from it. But sort of looking towards the future, what gets you sort of really excited about sort of graphs and how that fits in with different things?
So for me, I'm still, it's my graph of all of art history being public, and along the way, defining a new standard for digital art archives, which up to now has been Getty, which their standard for art archival data is how to write sentences about art and paragraphs about art, which is not helpful for computers. But it's, it's one good example of how carefully thinking about how to structure your graph can have larger positive impacts on the world. Because as soon as you have a intelligent, carefully engineered data architecture for something that up till now has never really been well represented in data, that pattern can be applied to lots and lots and lots of different things and can make it possible for new insights, new ML patterns, new algorithms that can tell us all sorts of new things and new discoveries and new insights about ourselves, about the world, about data in general, about logic, and that we're graph databases in general are just new enough, but just evolved enough that we're on kind of a new frontier, I think, and being a part of that frontier is just exciting to me. I love to explore, I love to create, and good place to be to do both of those things.
Absolutely.
Yeah, for me, I'm really looking forward to learn more about recommendations, using Neo4j for recommendations and analyzing. I've been toying with the idea of analyzing music pieces and find similarities between them, and also depending on the genres, how they correlate with each other. And yeah, I would like to do that in the future, to have a project in that topic.
Cool. What kind of recommendations? Is it sort of on the face of sort of albums and artists? Is it the face of actually taking that music and doing some kind of digital signal processing on that music? I'm curious now.
I haven't really thought the direction I want to go, but it could be recommendations based on depending on multiple musical pieces based on their actual structure, musical structure, to recommend something similar or something that's completely the opposite, and also to be able to improvise from a given part of a music piece, to improvise and generate something that might be enjoyable.
Oh, that sounds cool. Generated music.
Yeah.
I like that.
I want to. If you're working on something like that, I want to see it.
I haven't started yet, but I've been thinking of the idea of where I'm gonna go, and I will definitely start it.
Yeah. Hook up with me after this, because I've been thinking about that in the back of my mind a couple times before already. So
okay, cool.
So, even on a random live stream where
yeah, why not? Graphs can do everything.
Yeah.
Yeah, if that really comes into being a project, I want to see it, and that we have another live stream with you guys, and then you have a slot to present that, showcase it.
Yeah,
for sure.
Yeah.
There was another quick question that just popped up. What language was the back end of Neo4j written in? Was it written in Java? Because it looks like it was all written in Java, but I'm curious.
Yes, it's all in Java. All in Java. So, And imprecise, can we discuss any data structure concepts involved in graph developing databases? Oh, and Scala as well. Yes. So I believe on the languages side, they're also using Scala. And I think on the clustering side as well. So yeah, it's a mix. And yeah, as Michael's pointing out, so obviously that's the main database. And obviously we've got some of the applications in up top, and those are typically built in something in the Java framework. So JavaScript framework of some description. So
Michael will join us in a couple of minutes, so maybe he can dive into that topic a little bit more.
Yep. Absolutely.
Yeah, I know I built a plugin for my project, and it's it had to be all in Java. And starting at building a plugin for Neo4j is a challenge, but once you get how to inject the dependencies the right way, it gets really easy really fast.
Mm-hmm. Yeah, that's true. I've also built a plugin for my project at work, and at the beginning I was I tried to figure it out, and but once you figure it out and you find the correct injections and dependencies, then it's really easy.
Yeah.
And you can build some very powerful plugins.
Oh
yeah. Yep. Yeah. It's amazing what you can build. Yeah.
That's brilliant. Oh, and we got some feedback from Mike was just saying about let's work on building plugins, making it easier. So yeah, I think we should, not right now, but I think definitely we should chat and get sort of gather up user experiences and see what can we do to just make that process and experience better. Mm-hmm. But yeah, so I think
so I can help a little bit there. But not right now, I guess. But it really is. I think we need a little bit better getting started pieces, and a little more clarity about how far can you go into the API before you've gone too far.
Some warning signs: do not. No, absolutely no. So that's totally fair shout, and that's something we should definitely look into and dig in further. So I guess one thing, and we've mentioned it a couple of times, I think we're quite cool. So both of you are super active on Discord. So as we were chatting a bit earlier, so it's a relatively new thing for us. I think, did we start in February, March? I can't remember when
we started in going live in at end of March. So it's 3 months.
Oh, even earlier.
Yeah,
we thought we would love to take both of you as I kind of get the feeling you both experienced Discord users. I mean, I'm sort of mere Padawan, I'm kind of like Discord.
Mm-hmm.
Smiley face. I've mastered smiley faces and polls.
That's a good start. Yeah, exactly. Yeah, that's important.
The nice thing about Discord is that it's really just there to use, and it doesn't clutter things up with any complex syntax or formatting. It's just chat, find your answers, post stuff, you're done.
No, absolutely. So I guess should we do a quick Discord tour before we go, and you can have a quick look, and then we're going to invite everybody else, come join us. So I think it's discord.gg/Neo4j. Come along and say hello. So so very quickly, probably worth mentioning. So we've got we've got some super secret nodes tracks available, and I'm going to keep quiet. I'm going to let the experts talk about Discord. I'm just.
So we do have these various channels. So like you see here in the if you join Discord, you have a couple of channels. So maybe a quick whirlwind overview here. Top line is the announcement section. So this is where we broadcast tidbits from the internet, from around the internet. So for example, here in the Neo4j news section, you see the current updates from the Neo4j blog, or for example, here in release notes, you find updates from new posts on the new releases from Neo4j and the ecosystem. And then here in general, it starts with the actual content. So you see welcome channel that gives you a quick overview of rules and guidelines. Introduce yourself is basically your intro session where you start, and the banter is our general talk and nonsense chat group where we have to talk about the weather, talk about funny polls, talk about anything and everything. It's really open.
It's just a better name than miscellaneous.
Exactly. Yeah, or off topic is kind of
and there you go. And if you're really quick, you could have been spamming the banter channel whilst we've got it up on screen. So
yeah, there you go. Well, you can also see there. You can also see there. I left the game I was playing to keep myself awake until 4 a.m. It's still on. I thought I'd turned it off, but
it's a good game. I haven't played that yet. It's on my list.
Oh my goodness. Okay.
Very good.
So anyway,
you gotta have fun with it, right?
Oh, absolutely. Whoa, hang on a minute. Yeah, you're on double TV now.
Oh yeah.
So it's pretty quickly worth mentioning as well. We do so for those of you who are joining us with nodes later on. I hope you are. I mean, I'm kind of thinking that's why you've joined us for the pre-node stream. We have some super duper secret channels. We have chat channels. So Alex showing you here. So these are like the typey channels. You can see some of us have been active on the typey in that one. So you will notice these correspond to the tracks we've got today. And we've also got some audio channels too. So if you'd rather have a chat, you got little pictures of the little sort of speakers on there. So that starts and that'll automatically activate your camera. Don't worry, sorry, your microphone, not your camera, just the microphone. Don't panic. So yeah, so it's a nice little voice call, and it's probably worth quickly demoing because I know a few people have asked. So if you want to, you can have a chat, and then if you're finished, you can just press a little picture of the speaker and that kills the voice channel session. So if during the conference or maybe later you want to, you just want to chat about something that was interesting that you've learned, or you just want to, so you want to connect with people at the conference, your fellow conference goers, and you want to have a chat, this is a really easy way to do that. But you need to do the exclamation nodes to reveal the magic channels.
And there's one more thing about the voice chats that I'd point out is if you click on it once, it just connects you to the voice chat. If you click on that same voice chat a second time, it will show you all the visitors there, and people can share screens, turn on their video, and that's how you can see them. So if you click it again, that's how you can do screen sharing and even let other visitors take control of your computer if you need to. So if you're collaborating and doing things like that.
That's a good tip.
Oh, I learned from you. Hey, check that. Look, there we go. Live demo.
Yeah. Community-driven
live demo. I like this. And I want to see lots more of this during the conference.
Hey.
Yes, you are live.
Look at this.
Now everybody's on TV.
Exactly.
Everybody's on TV. This is brilliant. So yeah, so you can see, and this is what I really love about Discord. It's just so easy to be able to just dive into a conversation and chat. If you want to do the voice chat, you've got the voice chat. If you want to bring the video in, you can bring the video in. If you just want to keep it just typing, you've got that option too. So yeah, thanks for all of you for that super quick demo. So it's a great way to. I think it's a great way to have that seamless conversation, and you can see why it's so popular. Why
and
it's
if you're having trouble in just getting started, go straight to the Cypher channel and ask your problem, and just give us a sample of your graph, what you're going for, and we can get an answer for you.
Yeah,
absolutely.
Super cool.
My goodness! And it's probably worth mentioning we're going to try the experimental speed chatbot, which Alex has had a go with yesterday.
Yeah. It was really nice. Yeah.
Yeah. So probably just very quickly. So what the speed chatbot is, again, another shout out to Johannes. Brilliant thing. So basically what this bot will do So there's a process. So we'll start up like a start of the round. So you have to react to the chatbot when it says, hey, react to me. And then we hit the start button, and then we have an allocated time. And we've got a poll and banter. Some of you may have spotted we've got a poll to say, what is your time preference? And what will happen is when we start it, it'll randomly allocate you with another person. And then you'll have, say, 5 minutes to chat, and it'll automatically start up the audio channel. So what happens is it will ping you and say, click this audio channel to get started. So it will create the channel for you. You have your chat, and then at, say, 5 minutes, it'll unceremoniously kill that channel. So it's a great way to just meet new people from the conference super, super quickly, have a chat, say hello, and then carry on. So we'll try and run a few of those during the day as well. So keep an eye out for that. But experimental bot, so we'll see how it goes. But yeah.
Where would we find that?
So I think I'll probably run that in the. We can actually let's do decision here. So I don't want to run it necessarily in the separate Neo4j tracks, but I'm thinking we've got a nodes channel, so maybe we can do if we run the setting up session in the nodes channel, and that's probably a nice accessible way for everyone to come in. So yeah, we'll ping we'll alert everybody on Discord before, as we start the registrations. But yeah,
perfect.
Great.
Yeah, exciting.
Cool.
Sounds good to me.
Exciting, yeah.
Exciting.
Thank you very much, Anthony and Alex, really for taking the time to joining us, especially Anthony, 4 a.m. crazy man.
Thank you for
I'm always up for helping Neo4j, man.
Yeah.
You're very welcome. Thank you for having me.
Much.
Thank you so
Thank
much.
you so much for joining us.
And see you soon.
Yes, see you later.
Take care.
See you always.
Bye.
Super cool.
Yeah, really active members of the community, like always. And it's not the. I mean, don't get me wrong. Like, super appreciate the answering the questions and helping people out. But just being there, just generating the banter. Just both Alex and Anthony are always there. They're chatting. They're being friendly, and we've got lots of people in the community doing that. And I think all of it builds that up. And you want to move away from this sort of like transactional, I ask a question, I answer a question, to the more of the, what projects are you working on? What gets you excited? What are you learning new? What things coming in that you're taking your interest in? I think all of it, asking about the weather, it's all good. I think it builds this amazing community, and it's really, really great. Yeah.
So one last time, we have a quick overview, really rundown before we slide in Michael as well for the final countdown. It's 25 minutes to go. So really, we are in the final stretch. So really, what is Nodes? It's our developer event today happening. I have a little bit of an echo. Why do I have an echo? Now it's gone. Yeah. 5 tracks, 50 talks. Almost all of them will be live. So it's really going to be good fun, interactive and engaging throughout the day with the community, with everybody that is taking part. So really do take good use of that. The closing keynote with Jim Weber, our chief scientist, and some selected members of the community as well, with a nice panel to close it all off tonight. And then let's check out a track. Again, thank you very much to our awesome community partners supporting us in making Nodes 2021 happening. So really, really good. And yeah, the final track we haven't talked about today is the best practices track. It's one with a couple of cool selections. It's again with the Cypher Merge Explained. That is the one that Luan hinted at earlier today. A couple of other ones. Lou, do you want to give a quick?
Yeah, absolutely. So just a quick introduction to this track. So as the name suggests, this is all about sort of best practices of doing something, so approaches of doing things, considerations, that kind of thing. And just a quick run through the various talks that we've got today. So as Alex highlighted, we've got Luan's talk about Cypher Merge Explained. So we have got a session on text. So the interesting thing about text, so it's a project that has been running for 11 years, and just getting a bit of an understanding about it. So it's not a big, it's a reasonable graph. So, looking at sort of 300,000 nodes and 80 million vertices, so just tracking how these changes around sort of this editing function works, and just, celebrating a project that's been running a while. and how it fits in with graphs. Then we've got MLOps. So again, we've had quite a few talks that we've so far mentioned earlier. So we had a couple in the data science track, and we've got another one here. So basically, this whole idea of, well, okay, so we've talked about, obviously data science. We explore stuff. We talk about how, what this might look like with graphs. But then it comes to this idea of, well, how do you productionize that? So we've got a few talks talking about, well, how do these things start to fit together? How do you take your machine learning models and do something with that? And then we have got link prediction. So we've got a couple of link prediction talks. We've got this one here. We've got one as well in the data science track. Another fraud one, another one about this sort of idea of transparency. So this is where, again, bringing the combination of machine learning approaches, supervised learning approaches, and being able to bring this sort of explainable knowledge. So explaining how you've spotted this fraud and these approaches behind them. I've got a couple of GraphQL talks in there. So one about security. So as you mentioned earlier, Alex, so the GraphQL driver was released last month, like the official product supported one. And there's elements around there. So there's elements around, well, okay, great. We've got this really powerful thing that allows us to build an API and how we query data back and forth and that kind of thing. And obviously the consideration now extends to, well, how do we secure that? How do we lock that down? And then later on in the day, we've also got best practices. So the really nice thing about GraphQL and when you're building a schema is, yes, you can do that one-to-one mapping between what you've got in your graph database and what you're pulling data out and back and forth, and obviously select things. But the really nice thing as well is you can further tailor that. You can use Cypher to further lock down and tailor and almost create views within your GraphQL schema with how that works. And you get discussion here about what are the best practices around that. As Priya mentioned earlier as well, we've got Ashley Faith, who's coming and doing a session on how do you do equitable search, so building out knowledge graphs and how you make that fairer. We have got a lightning talk on schema design demystified. So effectively, how can you use, how do you sort of spin it ahead and look at your architectures and how you do that design? And we've got one more, which is graph integration in the cloud. So this is all about if you are using, for example, Neo4j Aura, a cloud instance, well, how does that fit in with all the other components that you've got available in the cloud? So how do you take advantage of all the other services and start bringing it together in this modern architecture? So that's a brief overview of the 5th track, which is best practices.
Cool, great. Thank you very much, Lou. And with that, I think we have almost on the dot 20 more minutes to go until email opens up Notes 2021. Therefore, I'd like to welcome Michael Unger to the stream. Welcome, Michael. Hello, hello. Thanks for joining us.
Yeah, happy to. I've been watching since the morning. I was on the balcony, sitting in the sun all morning, watching you. So super, super fun. Lots of great talks, interviews. I really liked Polly's Jita because, architecture, pattern languages is something that's really close to my heart. I love whiskey. And so Luan's was also great. And knowledge graphs, pulling in data from different sources. And so Rajesh was also really close to what I love to do. So good selection that you picked from that perspective. So thanks a lot for entertaining the whole world before Notes starts, and great job.
Thank you, Michael.
You know what? We're going to ask you the first question. Which talks are you looking forward to? Which one?
Yeah.
That's
actually, I was looking at the agenda, and it's really tough, right? So there are so many good talks, and it's really, really tough. So actually, kind of being a Java person and Java champion, of course, I love the Java talk. So our colleague Garrett Myatt is looking at how can you integrate Neo4j via the Neo4j driver in all kinds of modern Java frameworks. So Micronaut, Helidon, Quarkus, Spring, building native images using GraalVM. So this is really something that's very, very close to what I love to do. The other one that is also really cool is the GraphQL talk in the Neo4j track, because as some of you might know, GraphQL was actually started in 2016. then I was asked by Rod Johnson, the creator of the Spring Framework, if we could add GraphQL support to Neo4j. And so it was for many years a DevRel project, Neo4j GraphQL. And now since April 27th, it's actually an officially supported, productized library that everyone can use. And I'm super excited about the hackathon that we ran and kind of what's coming there, because I think making it easier to build apps with graph databases is actually a really, really important aspect. So that's these are two from the Neo4j track, and actually a lightning talk in the Neo4j track from my colleague Adam is really cool because he basically used Neo4j itself to make our developer page experience better and the Graph Academy experience better. So kind of really dog fooding that. So that's one that I really love. Okay, let's look at the other tracks. The Spark integration is also really nice, because that was also one project that was started in DevRel, and kind of seeing it graduate and seeing it being picked up by so many users and customers. It's really nice, kind of the re-implementation on the Spark data source API, which now enables Python's R and Java Scala usage. It's really cool. And Tomáš's NLP talk. I know that Tomáš's NLP article was the most viewed article that he ever wrote for Towards Data Science. So it was really well received, and turning that into a talk was, I think, a really, really good decision. In the visualization one, I would really love to see the low-code one, creating your first graph visualization low-code approach, because that's something that kind of democratizes access to building tools to a lot of people, right? So if you can build a tool not knowing kind of programming languages really deeply, then this kind of allows more and more people to build really cool tools. On the tracks and API one, that's a really tough one, because there were so many so many good ones. I think the voice control one is really nice, together with the Unreal Engine one, kind of moving interactions out into the physical space, kind of from typing on your keyboard or touching your phone to become like more the future of like Star Trek and kind of where we just interact with our technical companions more naturally. So I think those are both really, really nice. And closing, Luan already mentioned merge. So I love merge as a concept and keyword. And was back then, I was there when it was added to the language as well. So I think it's a really powerful concept. And tech, the tech one is really interesting as well, because I wrote my thesis in tech, and basically that's kind of reminiscent of back then, like many years ago. I think 20-something years ago when I wrote my thesis. So kind of that's a nice trip to the past to say so, and see that's come from there since then. So this was quite a lot, but it's really tough to pick talks, and I think gladly everything is recorded, and so we can watch them later, put it on your big cinema screen or home projector, and have your own home conference. If you have friends that you can visit, perhaps you can do like a private viewing party of the recordings later on.
Funny you should say that, because Kim and I were having a conversation earlier, and we're thinking if we can try and organise a virtual viewing party on Discord. So let's see if we can try and pick talks one at a time. And I think Discord's really beautiful for this, in that you can have one person sort of shares up the video, and then we can still do the type chatting or the audio chatting, and we just watch the session together. And I think
commenting on the
why not? I mean, it's always nice
so.
if you can do it, watch it live. But next best thing is get a group of like-minded people together, and you're watching it live together, even if the actual thing is a recording. Yeah,
especially live commentary, right? So I can then comment on stuff that you're seeing and have some fun together. So that's definitely good. Oh, I missed one talk actually. Which is actually Eamon's keynote. Which is really cool. So I had prepared for that one. And there are some really cool things coming. So I can't tell you anything, but be there, see it. And we have 14 minutes to go, and I can't wait to see it happen. And really cool stuff that will come in the keynote. So stay tuned for that one. That's definitely a thing to remember for the future.
Yeah, for sure. I'm looking forward to that as well. That's gonna be very cool. And don't miss like we said a couple of times, don't miss the closing one with Jim. I think that's gonna be a particular fun session towards the end.
Yeah.
And then maybe one thing to remember is that we have Q&A sessions and panels throughout the day as well during the notes presentation. So you can always interact with the community, interact with speakers, interact with everybody from Neo4j who will be obviously attending the day. So make use of this.
Yeah, that's a really good point, Alex. So we want to encourage everyone to ask as many questions during the talks, which will then be collected for the Q&A panel, so the speakers can answer them together. Also, if you have like multiple speakers from the same topic area, so different people can chime in for the same question, and so it's much more interactive and than just answering one question after the other by a single speaker. So I think this setup is a really good idea to also make use of the fact that we now have a live conference again, which I really love personally. So please ask as many questions during the talks as possible, and a number of them will be picked for the Q&A session then to be used there.
Yeah, and a quick reminder to everybody as well, just if there's a speaker or a talk that you're really excited, that you're looking forward to, if there's a talk that you've been to and you learned something new or something exciting, please reach out on social media, sort of tweet the speaker, say why you enjoyed their talk, say why you're looking forward to that talk. It's a really great way to sort of recognize them in a public platform and just let them know that you're really excited. So please do that as well.
Yeah, I've been already tweeting this morning.
Being very productive.
Tweet along for
exactly. Don't forget to add hashtag.
Hashtag Notes 2021.
Yeah, I think that's really good because, as you said, that really kind of appreciates the speaker, but also shares for people that have not seen the talk because they couldn't attend or whatever. They see kind of interesting tidbits from the network, and then would also encourage them to watch it later as well. So it's really not about sharing the knowledge and sharing what you learned. And if you have any opportunity to do that, take screenshots or screen grabs, or take a picture with your camera with your phone. Doesn't matter, and just capture the moment in a way.
Absolutely.
Cool. So we have 10 minutes to go. Do we have any questions or topics that we want to talk about? So we can talk about anything that you want.
So Matt W, about, I think it was 4 hours ago, I don't know, I've lost count now. Anyway, I asked the question. We started a little conversation in the YouTube chat about, so the sort of following comment from when we were chatting to Priya about, well, okay, so why would I ever use a relational database again? And so I think we put in a couple of examples that, it's the right tool for the job. So if you are looking to explore your connected data, then, that's what you would do. Obviously Graph's a great fit for that, Neo4j. If you're wanting to do lots of sort of, for a better description, if you're doing things like, I want to figure out an average wage of my company of like X million X employees, or I want to find out the average height per country per something, then that's a very sort of, that's probably where you stick to your tables and do that kind of stuff. So I guess probably worthwhile us expanding on that a little bit more. I know it's a very common question, but it's always going to keep being asked. And I think it's always good to be honest about, picking the right tool and that kind of thing.
Yeah, that's true. So as you already mentioned, so everything that's kind of related to things like data warehouse type questions, right? So where you have large data sets that you have to analyze, just basically number crunching tables, most likely single tables because they've been denormalized into like a 500 column table, and then you just number crunch over them. So their relational database or a specialized system like Snowflake or Databricks are actually more suited for these kind of at least terabyte or petabyte size graphs, data volumes. The other thing is if you have kind of high event stream like time series data. So for instance, there's time series DB and InfluxDB. Some of them are built on top of Postgres. So if you have this kind of really similar structured data that's just coming in, and you might keep it in Kafka or something like that, but you might also want to put it in time series database and then have sliding windows over the data and do analysis on that. And then also if you want to store large volumes of binary data like images, videos, things like that, megabytes of text, then that's not what a graph database was originally built for, right? Graph database is really about the connections, about the topology, about the richness of the data model as such, right? On the other hand, I often said, actually, if you look at graph databases, they're kind of like the next generation of relation databases, right? So they're still transactional. They have a fine-grained data model. You can query ad hoc from every point in the graph. You don't need to pre-compute certain things. You don't have aggregate like in document databases. So you have the flexibility of a relation database. You have the safety because it's still transactional and asset, but you have the benefit that kind of this concept of a pointer to somewhere is actually turned into something that's native to the database. So it's no longer a table that has been tortured into keeping links, basically, like join tables. I've been in projects that had hundreds of tables and then like 3 times the number of join tables, basically. And then you had like 1,500 join tables for 500 tables or something like that. And even Oracle died under like queries with, 10 joins, 5 joins, things like that, like tree queries or path queries or complex navigational queries and so on. So from that perspective, actually, I often feel that kind of graph databases took the next step where kind of relation databases stopped in a way, because if you look at the relational model, kind of foreign keys and join tables feel a little bit like, in retrospect, attached to the data model, because initially it was just forms, like one table per form, and that was good enough, right? And then basically all the join aspects and pulling things together only came later in the model as such, right? So you also see the syntax is kind of weird and not as nice as the rest of SQL and so on. And so graph databases basically took the real step to making relationships first-class citizens and focusing on them as well. And so from that perspective, actually most domain models that you deal with can be represented as a graph, and oftentimes also should be. What's interesting is actually looking at the data in terms of how flexible and how frequently is it also changing, right? So you have like your core data, like for instance, movies and actors or people or books and authors or things like that. And then you have like transactional data like purchases, views, and things like that. So that's something where you can actually take your core data in the graph and then put the transactional data either into a time series database, or you can actually use a graph database to scale out and then have large volumes of this kind of transactional data. And then, so I think that's something also close to your heart, Lou, is when you're dealing with graphs, you need to be a little bit more smart about what you're doing, right? Not just kind of dump everything in one place and then hope for the best, but it's kind of, you know domain best, and you know exactly how things are related, what's important for use case. So use this knowledge and tell the database about it, so it can also make use of the same knowledge, and then it will help you a lot actually solving these use cases as such.
Absolutely.
Yeah, that's my little pitch for.
But well, the interesting thing as well, I think, is when you start thinking about the tools, it's like you start pushing to extremes, because as soon as you start getting to these extreme edge cases, this is when it really becomes clear what is the right data store for the problem you're solving. So, I mean, yes, let's take storing blobs. Yes, theoretically, you can store blobs in Neo4j. I mean, that is something you can do. You can go off and play with the settings. Probably don't want to do that. But the point is, it's much like, yes, you could go off and take your 10 join thing you're going to have in SQL, and you could denormalize that into a massive table. But obviously, you just start bringing pain points back in. So such as, well, what happens when you have a data update and you've now, you start, what you think about denormalized table, you have to set up a pipeline where you're basically pushing, you're pushing that process where you're converting these expensive joins like every X minutes, days, hours, whatever you're set up to do that. And then obviously as soon as you've got an update, well, okay, you've got fun. Yes, you can do those, but it's just like it's unnecessarily painful. And much like, yes, we could go off and get our graph and have, I want to start doing like sort of average values of salary to heights as an example. Well, yes, you can do that. But if you've got vast quantities of data, then it's like,
if that's your main use case, then it's not kind of pointless, right?
Yeah, so we can start forcing those.
Yeah, exactly. Yeah.
But yeah, no, it's really, super, super cool. So hopefully, Matt W, if you're still with us, we've provided a bit more clarity and colour to your question. But yes,
yeah, we also have a page on the developer pages that talks a little bit about graphs versus relational databases and also NoSQL databases as well. Oh, Matt was still there. Cool, super.
So we've got a few minutes left. I think this is now a quick reminder. This is when we need to start sticking all the links up. So Alex, I think you've got like a call out there. So we need to put the call out for Node registering, just so that it is, just so that everyone can see it. So you've got your last few minutes. If you've not already registered, if you want to get your colleagues in, if you want to share, get, friends, colleagues, family, acquaintances, tweet it, all good. Now is the time, last few minutes until we start the keynote.
Exactly, last chance to register. I mean, not really, but last chance to register and get everything live.
And watch it, exactly.
Watch live, exactly.
And be able to comment live. And the thing is, we will not be streaming the keynote here. So this is your last chance. If you want to watch the keynote, you have to register. It's instantaneous, it's quick. So you've got the last dying moment. So, and we'll be probably going off air in the next sort of minute or so. So your last chance.
Yeah, so the keynote will be then afterwards available on YouTube as well. For people that miss it, can watch it on YouTube as such as well.
So I think with that last dying remarks, register. Tweet.
Go there. See Emil.
Something exciting.
Emil got a new haircut, so you should see his new haircut as well.
Yeah, if nothing else, go see the new haircut. I mean, that's got to be worth it.
Yeah, that's totally worth it. Yeah,
exactly. Discord. So if you're on Twitch, it's exclamation mark. Did we say exclamation mark Discord? Anyway, it's dev.neo4j.com/chat. Come join us on Discord. Come have a chat. Don't forget to register for Nodes. And I guess we'll see you all later. Oh, apparently there's some we need to do some heavy metal warm. Okay, right. For Nodes 2022, we'll try and see if we can do some heavy metal warm-up music, which somebody's just pinged we should have done.
Yeah, totally.
Well,
I mean, I can take my guitar, but I'm really bad at playing the guitar.
You've got a year to practice.
Yeah, exactly.
Yeah.
We have 1
I
year.
guess I need a year. I need a full year to practice.
Oh my goodness! Right.
Yeah.
In that case, the last 9 seconds. Enjoy Nodes. Happy conferencing.
Yeah.
Thank you so much.
And let us know what you think. If you have any feedback for pre-nodes or nodes or anything else, please let us know. We'll always try to get better. And it's been quite a ride to get here, but we're really happy for today. And
exactly.
Wish you an amazing day.
Thank you to all the guests. It was really amazing to have you all live on this.
Yeah, that was really cool. That was a great idea. Yeah.
Both live on here and interacting with us on the chat as well. All of you viewers, it's been great. We've been having some fun conversations. It's like we've had two.
Yeah. So should we count down? 9, 8, 7, 6,
5,
4,
3, 2,
1. Go! Go and watch.
Happy conference.